Hello. 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 I think I have no issue today in this class. Just give me confirmation so accordingly I can start right now. I think no problem today. I think I have no issue today in this class. I can listen even voice also on my laptop, but I'm not getting any kind of problem. Okay, fine, working fine. So, fine, guys. The one chapter, even it was many dimensions. Those I have finished with you. That was a energy. Okay. Okay. So no one have issues. Fine. So I think there is no issue with all of you guys from the previous lecture. Means one of the unit I have discussed, and in this unit there is a three chapters. Okay, three chapter. The one as a general mode of energy, renewable, non-renewable. Second, I just make a separate topic as a nuclear energy, and third topic, I hope you people remember, it was a nuclear diplomacy. Okay, so three separate topic I made. A part of it, guys, even social issue part that is connected with the energy, I have also discussed with you. Where you people got the questions from the Uday and the net metering. And one more question that even if you people solve UPSC question paper, Bureau of Energy Efficiency star rating. Okay, this type of question even also UPSC demand, and I have discussed with you. So you tell me, guys, that you people have no issues with the energy. So now I'll start finally with the next chapter. That is a space technology. So next chapter, that is space technology. So come on next, that is a space technology. Okay, see actually few terms which are very, very important, and even in the beginning you should be very clear these terminology. What are these terms? Listen, just like one term is called as a satellite. Okay, I have seen guys most of the people even having a problem to understand these basic terms like satellites. Second term, this is called as shuttle. Third term, this is called as launch vehicle. Fourth term, that is sorry, spacecraft. Okay, spacecraft. Fourth term is the launch vehicle. Fourth term is the launch vehicle. The fifth one is the rocket, and next one is the missiles. Okay, these are few terms, and I know, guys, whenever I have asked these questions in the class, so mostly people even confused with all the terminologies. So definitely here I'm going to start space technology. So first of all, I would like to clear these all the basic terms. So generally most of the students have a problem to understand all this terminology. Okay, so what are the terms like satellite, shuttle, spacecraft, launch vehicle, rocket, and missiles? Listen, what are these actually? Here I will advise you, you start first with the spacecraft. Okay, you people start first with the spacecraft. What is a spacecraft? So in general, I'll tell you guys, a spacecraft is what generally all those objects we are going to send in the space. In a very general manner, I can tell you, all those objects we are going to send in the space, this is generally called as a spacecraft. So in one line, all those object send in a space, send in a space. So all those objects we are going to send in the space, this is called a spacecraft. So what is a spacecraft? All those objects we are going to send to the space, this is called spacecraft. First point. Okay, second point, you listen guys. So all those objects we send in the space is called a spacecraft. Okay. As like simple example, satellite and shuttles, these all are the examples of a spacecraft. So I can tell you generally as a satellite is a spacecraft, shuttle is a spacecraft, because both we are going to send in the space. Fine. Now another questions. What is a space? What is space? This is another question. What is space? And you must be clear what is the space, guys. First, this is very, very important. What is space? You just listen, guys. Actually, officially, one of the specific place beyond it in space technology is called as a space. This is called as a Kármán line. This is called as a Kármán line. This is called as a Kármán line. The Kármán line is a distance from the Earth, guys, up to 100 kilometer. So 100 kilometer beyond. 100 kilometer beyond. 100 kilometer beyond. Okay, if you are available, guys, so you are in the space. So from the Earth's surface, if you across this Kármán line, and where is the Kármán line? From the Earth's surface up to 100 kilometer height distance is called as the Kármán line. So if you people are beyond the Kármán line, so you are in the space, you always remember. Okay, so beyond Kármán line, you are in the space. Okay, you guys are in the space. Fine. So generally, we are sending the spacecraft beyond this Kármán line. And see, this Kármán line is generally measured from the Earth's surface, not from the ocean bed. You people remember. Because here again, many people have a questions. Sir, the distance is from Earth's surface, yeah, you people know very well. Even different location have a Earth's surface have a different height. Does not matter. Does not matter. Even the peak of Himalaya, you see the highest peak, that is K2, 8,848 meter, hardly 8 kilometer. How much distance, how much the gap of the surface you can find out? It's negligible. 6, 7, 8 kilometer distance are negligible. Okay, even 1, 2, 3 generally kilometer distance. So generally you people remember from the Earth surface 100 kilometer beyond is the space, and this is officially called as a Kármán line. You people remember. Okay, so generally spacecraft, those all the objects we are going to send in the space is generally a term used is called as a spacecraft. Satellite I can tell you as a spacecraft. Shuttle I can tell you as a spacecraft. Even Chandrayaan, Mangalyaan, these all were the spacecraft, guys. Okay, so everything generally called as a spacecraft. Now another point. Now the question is, what about the satellite and what about the shuttle? Okay, fine. Generally, these all are called as a spacecraft. But question is, what about the difference between the satellite and shuttle? So you come here, guys, just to know about the difference between the satellite and shuttle. Come. So this side, you come into the discussion of satellite. So one side you come into the discussion of satellite. Okay, discussion of satellite. And second side, I'll go into the discussion of shuttle. Okay. You come here, that is the discussion of shuttle. So this is shuttle. So one side is the satellite and second side is the shuttle. Okay. So one side is the satellite and second side is the shuttle. Now come. Satellites. Okay, whenever you people do the study of satellites, satellite always describe in the respect of orbit. So satellite study always come in the respect of orbit. Satellite always describe in the respect of orbit. Now another question. What is orbit? Satellite always describe in the respect of orbit. One point. Now question is, what is orbit? Listen, guys. Orbit means attraction. Orbit means attraction. Attraction. What is the attraction of satellite? Definitely Earth-based gravity. Earth-based gravity. Okay, because those satellites we are going to send, it is an artificial satellite. I'm not telling you about the natural satellite as moon. So definitely those satellites we are going to launch, we are going to send in the respect of Earth. So in the respect of Earth, those satellites we are going to launch. Okay, it is under the Earth orbit, yeah, it is under the Earth attraction. If satellites are under the Earth attraction, so we can tell here the satellite is under the Earth orbit. If the satellite is outside from the Earth attraction, so now I can tell you satellite is outside from the Earth orbit. So here I can tell you, guys, orbit wise, there are two types of orbit where we are going to put the satellite. The one that is called inner orbit. The one that is called as a inner orbit. And the second is called as a outer orbit. those satellite discussion we are doing here as a inner orbit and the outer orbit. What is this, guys? Listen, inner orbit means what? Inner orbit means satellite is under the earth attraction, and outer orbit means satellite is outside from the earth attraction, means outside of earth gravity. Now question is, from the earth's surface up to how much distance earth orbit या inner orbit या earth attraction या earth gravity present? तो answer is up to 36,000 kilometer distance. Up to 36,000 kilometer distance there is a earth orbit या earth attraction or earth gravity present. And what about the outer orbit? More than 36,000 kilometer distance from the earth's surface. Now you are not under the earth gravity या earth attraction, so you are in outer orbit. And definitely, guys, it's very simple. Suppose I am taking your face-to-face classes. In face-to-face classes, generally what happen in the class? Many rows, chairs are in different rows are there, guys. And see, suppose there are 10 rows in my class. Till last wall, there is a total 10 rows in my class. And every rows have a 15 chairs. So total how many students in my class? Suppose 150 students in my class. So till last row, it's my orbit. This is the first row. I can tell you it's my first orbit. And you all people are in the chair. I can tell you all people are the satellites actually fixed up into the orbits. Now the next one is what? Second orbit. Second orbit again have what? That is the that have a different chair, and chair have a you people. So I can tell you it's a different satellite. Those are placed into the orbit. So in that way have a total 10 orbits where you people are seated there. Actually these are the orbits where the satellites are there. In that way remember. Up to the last row it is my orbit. It is called inner orbit. But it does not mean outside of the wall have not any other classes inner orbit, definitely outer orbit. But here you people are not under my attraction if you will be outside of the wall, guys. So inside the classroom, okay, till last row you are under my attraction. This is called as the inner orbit. This is called as the inner orbit. Inner orbit means my attraction is present. And whatever I will tell you guys, you all people will work for me because you are under the earth orbit, yeah, you are under my orbit. This is the reason those satellite you want to use for communication purposes of India, yeah, any countries. Navigation purpose for India, yeah, any countries. So these all the satellite you will launch under the inner orbit. There are different LEO, MEO, GEO, many of the orbit discussion I'll do later on. But first you try to understand about satellite in the respect of orbit. So satellite always describe in the respect of orbit. Even those Chandrayaan, Mangalyaan you are going to launch, you have launched even. These all are outside from the earth orbit. Those Chandrayaan and Mangalyaan type of satellites you people have launched, a spacecraft you people have launched, it across the earth orbit. It is not under the earth attraction. Then it enter into the moon and Mars orbit. And when it will enter into the moon and Mars orbit, so it will provide the data about the moon and Mars. If it will be under the earth orbit, so it will be not your users, guys. Purpose will totally different. But your purpose in the case of Chandrayaan and Mangalyaan to take the picture and images of the moon surface, even moon resources. Similarly in the case of Mars mission. Okay, so Chandrayaan and Mangalyaan are what? We people send it into the outer orbit. Okay, so Chandrayaan and Mangalyaan we people send into the outer orbit. It is a general concept you remember. Okay, in that way you people remember. Fine. Now the next point, guys. So satellites is what I hope you understood, guys. Satellites have a multiple purpose, and purpose wise satellite discussion I'll discuss later on. You just try to understand what generally satellite is. Fine. Next point. Satellites not reusable. So satellites not reusable. Satellite not reusable. Satellite not reusable. It means those satellite we are going to launch into the space, guys, it will never come back. We cannot use further the satellites. Okay, those satellites you launch once, guys, it is already there, it will never come back. Even I hope you people remember 19th April 1975. You know, that day it was a history of India. 19th April 1975. Maybe you people know this very well. On this day, guys, India launched Aryabhatta with the help of Russian launch vehicle. And this Aryabhatta, after completion of its lifespan, still Aryabhatta is there in that orbit, guys. It never came back. So time to time, all these satellites, after the completion of lifespan, these all become as a debris or space junk in the space, guys. So, and this space junk or space debris was actually called as a Kessler syndrome. So what is the Kessler syndrome? Kessler syndrome is nothing. It is the term used for the space junk or space debris. Those are going to create time to time in the space, guys. Just like I can give you one more example, guys. These all the satellites after completion of its lifespan, these all become as a Kessler syndrome or space junk. If suppose some casualty happen and some satellite has done the collision with the another satellite, further many debris is generated. These all debris is even called as a Kessler syndrome. First time these all the problems even identified by Kessler was the name of person, and that's why with the name of this person this is called as a Kessler syndrome. So Kessler syndrome is related to space debris or space junk, nothing more. Okay. So attraction means orbit, everybody clear? And one thing more I told you guys, like those satellites we are going to launch in the space, after completion of its lifespan we never carry back. So with time they are going to generate and accumulate into the space and become as a what? As a debris or space junk. And generally the common name of space junk or space debris are called as a Kessler syndrome. It is a good question for your paper remember. Okay, it is a good question for your paper, you people remember. This is an important one, guys. So what about the Kessler syndrome? You people know very well. Another thing, guys. Astronauts are the cosmonauts. They will never go through satellites. So astronauts are cosmonauts. So astronauts are cosmonauts. Astronaut are cosmonauts. Never go through satellites. And the logic you people know very well because it never come back. So if not come back, cannot be used further. So how this astronauts or the cosmonaut will come back? Actually, astronauts and the cosmonaut both are same, but difference is here. Cosmonaut term generally Russian used. Neither worldwide every countries they are using the term as a astronauts. If for India, America, European country, they are using astronauts. Neither Russian generally use the cosmonaut. So astronaut and the cosmonaut have no problem. You better remember both are same. Any Russian astronauts are going, so they generally use the term cosmonaut, not the astronaut. So country-wide terminology is used. So don't be confused with the astronaut and the cosmonaut, both are same. But Russian generally use cosmonaut, they never prefer the astronauts. Fine. So it's a information about the satellite. In very layman term, I just describe you. More technical part is important for your examination. But to come and enter into the satellite and more technical part, first of all, you come into the basic part. Okay guys, fine. Now you come into the shuttle, guys. Shuttle. Now I'll describe shuttle. As in the beginning I told you guys, satellite and shuttle both are the example of a spacecraft. I just categorize what about the satellite. Now you just listen what about the shuttle. Okay, now you listen what about the shuttle. Actually guys, shuttle generally used in space delivery system. This is the kind of spacecraft those generally used in space delivery system. This is generally used in space delivery system. It is generally used in the case of space delivery system. You people have a many questions here. What is the meaning of the space delivery system? See guys, space delivery system means what? Very simple. If you want to send the astronauts on the cosmonaut in the space, if you want to send astronauts or the cosmonaut in the space, so you people will use the shuttle, guys. Satellite never used to carry the astronauts and the cosmonauts, guys. But what about the shuttle? Shuttle will use to send the astronauts and the cosmonaut in the space, you people remember. Okay, so shuttle used in the space delivery system. If any it means I can tell you guys, Gaganyaan is a kind of shuttle. Okay, is a spacecraft. Gaganyaan is a spacecraft, but which kind of a spacecraft? Shuttle type of the spacecraft. I hope you people remember. Okay, so in that way you people remember this is what? This is a kind of spacecraft. One more point, another point, guys. You just come. You come into the another point here. Shuttle have a life support system. Definitely, if you people have a planning to send the human being, so you must have to provide life support system. Okay, you must have to provide life support system. Shuttle is reusable. Shuttle is reusable. It will come back and further it can use for the next mission. So shuttle is what? Shuttle is reusable. You people remember. Okay, shuttle is reusable. Second point. So shuttle is reusable. Shuttle is reusable. Okay, shuttle is reusable. And third point, guys, from shuttle, we people can connect EVA. EVA. Many years back, you know, EVA was the question. EVA is also called as a spacewalk. EVA is also called as a spacewalk. What is the EVA? EVA is what? Extra vehicular activity. EVA is what? This is extra vehicular activity. EVA is what? Extra vehicular activity. So EVA is what? Extra vehicular activity. Okay, EVA or you can call as a spacewalk. Actually guys, whenever the astronauts will enter into the space, okay, through the help of shuttle, now they will move out from the shuttle guys, okay, and do some activities that is called as a EVA, extra vehicular activity. Within the name already all features are given there. Extra means outside, vehicle after outside from the vehicles, and whatever the activities astronauts and the cosmonauts are going, this is called extravehicular activity. In the common term we can call as a spacewalk. Okay, we can call them generally as a spacewalk. Okay, now the question is, what is EVA or spacewalk? So what is actually EVA or spacewalk? Within the terminology already features are given there, and in layman term, what is the EVA? This is spacewalk already defined. Okay, actually EVA, there are two types of EVAs. Generally there are two types of EVAs those we people are using. The one that is called as a tethered EVA, the one that is called as a tethered EVA, and second is called as a untethered EVA. So one is called as a tethered EVA and second is called as a untethered EVA. So there are two types of EVA you people remember. The one is tethered EVA and second is a untethered EVA. What about tethered EVA? Very simple guys. Suppose this is a shuttle. Suppose this is a shuttle. This is a shuttle. In the case of tethered EVA, the body of even outside from the shuttle when astronauts will go in the space guys. So the body of astronauts are connecting through, the body of astronauts is connecting through shuttle, through some tube like structure, okay, and from this tube guys, all entire life support system is coming from shuttle to astronaut's body. It is very simple too guys. Suppose this is the mother body, and this is what? This is a fetus. And fetus is getting nutrition through the help of umbilical cord, yeah, placenta, whatever you call in the beginning. Similarly guys, all entire life support system is going to reach these astronauts through the help of some tube like structure. Okay, but body is connected, not free from the shuttle guys. But what about untethered EVA? In the case of untethered EVA, this is shuttle. Astronauts move outside, okay, some instrument and devices, and then walk, and then finally after some time will further enter into the shuttle. If you people have seen a movie, Gravity movie, if you people have seen, some ladies and gents, even they have visited in the space, okay, and they were moving there with the help of untethered EVA. They were moving there through the help of untethered EVA. So better you people see this movie Gravity, okay, and through the help of Gravity you will understand actually in the form of picture and videos what is the untethered EVA. Okay, and EVAs are very, very important for the spacewalk. That's why astronauts can do various activity in the space. So again I repeat, there are two types of a spacewalk or EVAs. The one is a tethered EVA where body is connecting to the shuttle, okay, for every type of supports, okay, and untethered EVA, here body is free and independent. Okay, body is free and independent. See, EVA was a question in 2007, 2008. Okay, in that time it was a new inventions, those happened, and many of the EVAs was in the news that time. But still, Kessler syndrome and EVAs are very, very important. You people remember. Syndrome type of term generally used for the diseases. Okay, but don't be confused here. The Kessler syndrome is not have any kind of disease. Here the Kessler syndrome is connecting with the space diseases. You people alert it, and Kessler syndrome I am expecting in your coming year paper. Okay, in your coming year paper. Okay, so this is the basics information. I hope through the help of picture I define you what actually the tethered EVA and untethered EVA. You people can do very easily all these comparisons. So tethered EVA and untethered EVA. Okay, so tethered EVA and untethered EVA. Okay, tethered and untethered EVA. So I think you people have not any doubts, so kindly inform me. Like you people are very, very clear with all these type of terms. And I just to clarify about the satellite, shuttle and spacecraft, till here nobody should have any kind of doubt. Okay, just respond me guys, like you people understood everything properly, satellite and shuttle, and just some of the discussion of orbit I have also done here. I hope you also very clear. So just respond me that you people are very clear. So I'll go to the in the next discussion. Great guys, very good, very good. Now come into the another part about launch vehicle, rocket and missiles. Okay, here I'll tell you, you start first. Just here you started from the spacecraft. Here I will advise you, you start from rockets. Actually, rockets generally use for launch vehicle and missiles both. I can repeat, rocket kind of term generally used for launch vehicle and missile both. As here you people have seen, is spacecraft is satellite and shuttle both. Okay, but different purpose. Similarly here in the case of rockets. How to describe a rocket? In a layman term, I can tell you, rocket is a kind of motor. Okay, rocket is a kind of engine. In a very layman term, but don't describe in this way rocket guys. Okay, another people will think so that you have not a basic, but just for the concept you always remember, rocket is a kind of what? Rocket is a kind of motor or engine. We are doing a lot of testing of the rocket guys. Again repeat, we are doing a lot of the rocket testing. Okay, and after getting a successful test of rocket, you know what we are doing? This motor or engine we are going to install into the launch vehicle and we are going to install into the missiles. This rocket engine we are going to install into the launch vehicle or into the missile. This is the reason launch vehicle also called as a rockets. That's why missile also called as a rocket. Because within the launch vehicle and missiles have a different types of engine and technologies. Okay, we are doing the testing of rockets. I hope you understood guys. Okay, we are using the different types of rocket to send, even sometime you will get it like this is this rocket even NASA used to send this mission. Okay, NASA used this rocket means actually launch vehicle use. Within the launch vehicle this rocket technology was there. As a very simple I can tell you, within a vehicle those engine we are using inside your car, that engine is a kind of rocket, but entire vehicle is a kind of launch vehicle or missiles. Okay, this motor or engine testing, after successful test what we are doing, we implant into the launch vehicle and we implant into the missiles. If you people install this rocket into the launch vehicle, so the purpose of launch vehicle is what? To carry spacecraft into the space. Means those satellite and shuttle we are going to send into the space, it's sent with the help of launch vehicles. So launch vehicle generally used for constructive purposes. Okay, and this rocket if you people use into the missile guys, so missile used to carry warhead. Warhead means gola barud. Okay, arsenals type, and this is used for the destructive purposes. Okay, this is used for the destructive purposes. This is the simplest way to define it. It's a very simple guys. See, I have a pen. Those rifle you people can see, you imagine it's a kind of rocket engine. Okay, this rocket engine we are going to install, and now this whole entire system is called as a launch vehicle. Okay, and this is suppose satellite. Now the satellite is going to load by spacecraft. Okay, now this spacecraft will carry the satellites, put into satellite into the orbit, and this launch vehicle move away. But within the launch vehicle it is what? Within the launch vehicle it is what? So within the launch vehicle it is what? It is the rocket engine, motor. As a simple way you people remember it. Okay, as a simple way you people remember it. This is the concept in this case. I hope everybody clear. And similarly in the case of missile what we are doing, in the case of missile again this is the rifle is what? As a rocket. Now this is what? This is the entire missiles, but missile never carry satellite. Missile carry warhead. Suppose the warhead, many warhead you have loaded it. Now the missile carry the warhead from one place to another place. This is the system as generally is just as a basic concept. Okay, I just to describe you. Okay, fine. So this is the entire concepts. I hope you people very clear. Okay, this is the simple concepts, and many technical discussion is still required, but that technical discussion I could not discuss here. I just introduced the terminology because in the beginning these terminology should be very clear. These all the terms have different meanings and different purpose. Now we'll go and discuss the detail of all the terminologies and everything. Okay everyone, fine. Now you come next. So come into the next heading about orbits. So come into the next topic that is called as orbits. Now come next discussion, that is orbit. What once again here? What once again? Okay, rocket engine generally we are using into the launch vehicles, and then through launch vehicle we send a satellite settles, and if this rocket we install into the missiles, then missile will use to carry the warheads. So in defense purposes, so ultimately I can tell you space technology research is also connected with the defense technology. Definitely in the beginning you have problem, but after some time you will understand, because different uses of the space technology and defense you will see it is common, as just like example of cryogenic engine. Okay, but if you think so in the first day, within 15 minutes you will understand entire thing. So I'm just telling you, you keep patience guys. I just like energy you understood, but you have given proper time. You give me at least 3 days. In the case of space technology, entire space technology you will also clear. Wait. Okay, fine. So orbits, how to describe a orbit? So actually different parameters are given for the study of orbit. I have given 2 parameters for the description of orbits, and they same I mentioned in the book also. Okay, so different parameters for the study of orbit. One, study of orbit on the basis of distance. Study of orbit on the basis of distance. The one, study of orbit on the basis of distance, and second, study of orbit on the basis of position. So study of orbit on the basis of distance. Okay, study of orbit on the basis of position. Okay, study of orbit on the basis of distance, study of orbit on the basis of position. People started to ask me space station. Arey, just wait, keep patience. Space station type of discussion in the advanced level I'll go. Okay, अब suddenly you start to ask me space station. Wait, keep patience. I just told you, I introduced the terminology. Okay, better why not you are asking me, sir, why you could not discuss the PSLV? Arey, wait here. I am again repeating the same thing. I am just introducing the term. If you want directly I enter into the advanced level, so it's fine, but it's not my nature, because most of the students are non-science also. Okay, and science students also have a basic problem to understand and differentiate the spacecraft and shuttle people are not getting in my class. So just wait, keep patience, keep patience. Don't ask me any question this time. I just have started 30 minutes back this space technology, and you think so in 30 minutes you will understand entire thing. So why I am here for 70 hours, 60 hours classes? If you want to listen me in 30 minutes, you just wait a minute, wait. Give me some time. Okay. And UPSC is that examination, if you will not have a patience now, so this exam you cannot clear, trust me. So distance and position wise the study of orbit. Distance wise orbit, you just listen guys. The one that is called LEO orbit. LEO orbit. Okay, LEO is what? LEO is called as a low Earth orbit. The one is called LEO orbit. Okay. Second is called as a MEO orbit. What is a MEO orbit? Medium Earth orbit. Second is called as a medium Earth orbit. Okay. Second is called as a medium Earth orbit. Third one is called as a GEO. GEO means geostationary Earth orbit. GEO means what? Geostationary Earth orbit. Okay, and the next one is HEO. HEO means what? High Earth orbit. Okay, HEO means what? High Earth orbit. HEO means what? High Earth orbit. There is a study of orbit on the basis of distance. Study of orbit on the basis of distance. LEO, MEO, GEO, and HEO. Okay, LEO, MEO, GEO, and HEO. This is what? There is a study of orbit on the basis of distance. LEO, MEO, GEO, and HEO. Okay, LEO, MEO, GEO, and HEO. Okay, this is a study of orbit on the basis of distance. Second side, second parameter, study of orbit on the basis of position. Here you see guys. Okay, polar orbit. Okay, second one, inclined or transitional orbit. position, incline, or transitional orbit. Inclined or transitional orbit. And third one is what? Third one is what? This is the equatorial orbit. Position wise, this is called equatorial orbit. Position wise, this is the equatorial orbit. So polar orbit, inclined or transitional orbit, and equatorial orbit. So polar orbit, inclined or transitional orbit, and equatorial orbit. Okay, this is the position wise, and here you will get this orbit study on the basis of distance. Actually, there are some relation between the position and distance. That's why I mentioned here one side position, second side have distance. Okay, second side have distance. Now come. What about the LEO orbit? LEO orbit means if satellites are here at a distance of 50 kilometer to 2000 kilometer. If satellites are 50 kilometer to 2000 kilometer, see plus minus is everywhere, guys. So little bit plus minus everywhere. But generally you remember, generally the low Earth orbit from the Earth's surface 50 to 2000 kilometer distance is the LEO orbit. What about the MEO orbit? MEO orbit here distance is the 5000 kilometer to 20,000 kilometer around. 20,000 kilometer around. GEO, it's approx 36,000 kilometer. Here distance is fixed. Even exact distance if you go to, you can get it 35,800, 64, 74, 84 around. This is the distance. So better you people remember approx 36,000 kilometer. Okay, US use the term as in miles. So 22,200 something miles. Okay, but Indians we prefer kilometer, not miles. So that's why here in Indian books everywhere 36,000 kilometer is mentioned approx. And what is the HEO orbit? If the distance will be more than 36,000 kilometer, it will be the part of HEO, guys. It will be the part of HEO. It will be the part of HEO. And I just told you guys just 10 minutes back, like up to 36,000 kilometer distance. I hope remember, satellite is under the Earth attraction. This is called as the inner orbit. This is called as the inner orbit. And HEO is what? Now satellites is outside of 36,000 kilometer. So not into the Earth orbit, outside of the Earth orbit. This is called as the outer orbit. So this is called as the outer orbit. So what about the inner orbit and what about the outer orbit? I hope you people very clear. Okay, so what about the inner orbit and outer orbit? You clear? This here LEO, MEO, GEO is the inner orbit and HEO is what? That is the outer orbit. You remember. So inner orbit and outer orbit, you people remember. Okay, you people remember. Now, one thing, guys. If you people go on ISRO site and see the Chandrayaan, Mangalyaan, just I am giving you some examples. You go and see Chandrayaan 1, Chandrayaan 2, Mangalyaan 1. If you see, guys, so officially Chandrayaan 1 and Mangalyaan is written, ISRO launch in HEO orbit. Why HEO orbit? Because these all are in outer orbit across 36,000. So across 36,000 kilometer distance, every distance orbit is called as a officially HEO orbit. I hope now you will understand. If you see Chandrayaan and Mangalyaan, why this is mentioned on ISRO side, these are in the HEO orbit. HEO orbit conceptually means now outside from the Earth attraction, means outer orbit. Outer orbit means it's a HEO orbit. Okay, the problem is now you people have not the clarity of these terms. Okay, and you start to think about the space station, you start to think about the, sir, you discuss about Viger mission. So just wait, hold it, guys. Okay, keep patience, but don't worry, patience will come slowly and gradually with me. Teacher have a lot of role in the class, guys, not only to come and finish syllabus. This work to everybody is doing. I told you interest, I told you motivation, I told you guys confidence, everything should enter into the class. And another one, teacher should also help to the students to keep the patience also. So definitely slowly and gradually you will get it. Okay, so it's a entire concept. Now one more point, guys. Now one more point. Okay, one more point. And I also want to connect with everyone, guys. Okay, but sometimes it's difficult. This is the reason I just asked you, you people clear, just I want to see your messages. Later on I will go next. I just do it. Why I am doing? Because I want to listen you. I want to connect with you. It's in the online classes, it's looking like that the teacher is coming and finish the class. It's what? Modi ji ki man ki baat, this is something like it. This person is coming and delivering. No, no, no. I want to make it as a communication type. Two-way connections. I never want to one-way connection. Just I am going to deliver only, you are listening only. Here the classes are looking like very boring. I just want after some time, yeah, students are getting lazy. I think I should connect with them. Maybe the students are not focusing towards my classes. So in that way, I connect you and just to ask some questions also in between. Okay, wait guys. So yeah, I'm here about distance wise people very clear. Come on to the position wise. Polar, inclined or transitional and equatorial. What is the meaning of it? You see this globe guys, here I'll show you. Here I'll show you. This is the globe, everybody know. On this globe guys, and see, imagine this is a satellite. This is a satellite. This is a satellite. This is what? This is polar position. What is it? This is what? This is a polar position. I hope you know where is the pole. This is what? Equator position, equatorial position. If satellite is moving in this direction, satellite direction is this. So I will tell you satellite is actually under the polar orbit. Pole to pole, pole to pole, pole to pole. Okay, so position wise if satellite is moving pole to pole, it is coming under the polar orbit. What is equatorial? Equatorial means here the satellites will lie plane of equator. From the equator satellites are here guys, and now satellite is moving like this. Satellite is moving right, revolving like this. So this is what? This is equatorial position wise. What about the inclined or transitional? Any angle in between. Any angle in between means something like this, something like this, something like this. Inclined or transitional, or in this direction, in between, this one like this, this one like this one like this. This is called inclined or transitional. So satellites, those are working guys. Okay, in different positions where people install the satellites. And what are these positions? The position of satellite you can see here like polar position, inclined or transitional position and equatorial positions. I hope you people very clear. What about the meaning of polar, inclined or transitional and equatorial? Okay, and equatorial. Now you come. Leo orbit, Meo orbit and Geo orbit. This Leo orbit, those we are going to put, this position is into the polar guys. So what about the polar position distance wise? This is in Leo. Inclined position distance wise, this is in Meo. Equatorial position distance wise, this is in Geo. So you people connect in front of it. Okay, so very simple questions. My question is, what about the distance of polar satellites? So the answer is polar satellites are here into the low Earth orbit. What about distance of inclined or transitional orbit? The answer is what? They are into the Meo orbit. What about distance of equatorial orbit? So distance is what? That is approx 36,000 kilometers. So distance and position matter guys. Okay, matter guys. Now you can connect. So those I have done here, you people do same guys. Okay, and now everybody give me answer one, you people clear. Okay, so if whenever I will discuss about the polar orbit, yeah, polar satellites. So you people remember as a common sense, the satellite is at the distance of 50 to 2000 kilometers in between from the surface. If I'll discuss with you the satellite is into the equatorial position, the equatorial position means what? The satellite is into the geostationary Earth orbit, you people remember. Okay, you people remember. So satellite is actually into the geostationary Earth orbit, you people remember. Great guys. Okay. Polar distance you clear, inclined distance you clear, equatorial distance you people clear. Have no doubts right now. Okay, have no doubts right now. Now I'm going to erase entire parts. Even each and every orbits I'll discuss. Position wise, distance wise, everything will discuss. But first you listen all the brief. Inclined orbit means what? Polar, equatorial, in between those angle based satellite moving. In these views, both angles are inclined means something jhuka hua, bending. Now come next point. Why satellite not fall down to the surface of Earth, right? Why satellite not fall down to the surface of Earth? It was a question in 2011 prelims. Give heading, why satellite not fall down to the surface of Earth? Question mark. Why satellite not fall down to the surface of Earth? Come. So why satellite not fall down to the surface of Earth? Write it. It was a question in 2011 prelims even. Why satellite not fall down to the surface of Earth? Even satellites are under the inner orbit. Inner orbit means under the attraction of Earth. But still satellites are there. Why not fall down to the surface of Earth? Because Earth gravity attract all the satellites. There are some reason, guys. And this reason was UPSC question in 2011. Why satellite not fall down to the surface of Earth? Okay, it was a question, guys. Okay, now come here in this case. This concepts I'll discuss through chemistry, atomic structure. I hope you people remember atomic structure. Okay, school time into the atomic structure, our teacher taught us nucleus. Those have a proton and neutron. It is positively charged. And the surrounding have different orbits where electrons are moving. Okay, you see that picture again here, guys. I'm going to start from the zero level. So suppose this is the nucleus. Suppose this is nucleus. Okay, what is in the nucleus? So nucleus have a proton and neutron, everyone know. And nucleus is what? Positively charged. Okay, this is the first orbit. I hope you remember. This was the first orbit. This is the first orbit. This is the first orbit. And how many number of electrons into the first orbit? You people know very well. 2 electrons, I hope you remember. First orbit. Electrons have a negative charge. Electrons have negative charge. This nucleus attract electron. But still electron is moving here. Electron not fall down to the nucleus. Question is why? Why electrons are in that orbit? Why not reach down to the nucleus? Even nucleus have a attraction. So same concepts why electron is not coming here, same apply in the case of satellites. Similarly, guys, this is the second orbit. This is the second orbit. Second orbit have a maximum 8 number of electron. 1, 2, 3, 4, 5, 6, 7, 8 number of electrons. Again electrons are negatively charged. Again electrons are negatively charged. And again nucleus attract these electrons, but still electrons are there, not reached down to the nucleus, guys. Similarly, this is the third orbit. Just see, guys, this is the third orbit. This is the third orbit. The maximum number of electron 18. I hope you people remember. Imagine this is the 18 number of electron. This is the 18 number of electrons. Electrons again negatively charged. The same question, those I ask here, here, here. Why electrons are in the orbit? Why not reach down to the surface of nucleus? Okay, now you just try to understand here, guys. Okay, some concepts here, some concept here, some concept here, some concept here, some concept here. Now you imagine, guys, this is one of the satellite A at a distance of 50 kilometer. This is the satellite B at a distance of 5,000 kilometer. This is the satellite C at a distance of 36,000 kilometer. Okay, those picture I have drawn, you people also draw it. You people also write it. You people write it first. Okay. Now come. And this proton and neutron I will also remove here. I write it, this is the earth. This is the earth. And gravities are up to 36,000 kilometer, but still satellites are here, not fall down to the earth, guys. This is the logic. And the logic I'll connect through the help of one examples. Okay, you come here in this understanding. Suppose, guys, this is earth. Suppose this is earth. Just try to understand in this form. Earth. And from the Earth's surface, I'm here. From the Earth's surface, I'm here. My hand from the Earth's surface, suppose it's at a height of 50 kilometer. It is at a height of 50 kilometer. And I'm going to throw a ball. I have a ball, I'm going to throw a ball. Okay, just see what I'm doing. In the beginning, I'm throwing a ball with the speed of 3 kilometer per second. So what is the speed of ball? Those I'm going to throw 3 kilometer per second. When I throw a ball with 3 kilometer per second, okay, see this is a ball, and this ball I'm going to throw with the 3 kilometer per second speed. With 3 kilometer per second speed, ball is going straight, and then fell down. Okay, so 3 kilometer per second when I throw a ball. So for certain period of time, ball was going to straight, and then fell down. But I want to make this ball more distance, straight. So what I'll do, I hope you understand. Sir, better 3 kilometer per second as you said earlier. Now increase this speed. Just 3 you send. If suppose I increase the speed and now 5 kilometer per second I'm throwing the ball, what will come here? So now 5 kilometer per second, ball is going to straight, again fell down. So when I throw a ball with 5 kilometer per second speed, so for many duration of time, ball is going to straight, and then again fell down. But see guys, I want to make this ball straight, not it should fall down. So what I'll do, definitely you people know very well, and you will tell me this answer, so better you increase more speed. Now I'm going to maintain a speed around 7.9 or 8 kilometer per second speed. Yeah, 8.1 kilometer per second speed. Suppose 7.9 kilometer per second speed I'm going to throw a ball. Now what will come? Ball is going straight. Okay, speed is what? 7.9 kilometer per second. And now ball is not going to fall down. When I throw a ball with 7.9 kilometer per second, now ball is not going to fell down, and ball is going to move in this orbit, move, not going to reach down. So what is it? What is the conclusion here? Actually guys, to keep a satellite into the proper orbit, certain speed is required, and that speed is called as a orbital speed, and this speed is called as a orbital speed. So now answer is why satellites not fall down to the earth guys. Even earth attract as a gravity. So the answer is due to certain orbital speed. Even. So why satellite not fall down? That is because of orbital speed. You listen here guys. If I do the comparison at point A, at point B, and at point C, my question is here guys, if you people do the comparison at point A, at point B, and at point C, where is the maximum effect of gravity? Okay, at point A, at point B, or at point C, the answer is, I hope you people know very well, at point A, you know, if objects will be very close from the surface, gravity is maximum. If you are moving away from the earth, what about the effect of gravity? Is going to low and low. I hope you people know very well, when we are close to the surface, the gravity is maximum. But when we people are moving away, what is about the gravity? Gravity is going to decrease. So here you listen guys. At point A, gravity is maximum. At point A, G is equal to maximum. At point C, I'll tell you G is equal to minimum. And you people know very well, till 36,000 kilometer earth attraction present, that is the last. So definitely last gravity is here, as common sense you people can guess it. So here the value of G is maximum, here the value of gravity is minimum. And you know guys, here earth gravity attract very fastly towards the earth. And that is the reason here the satellites, those are moving. Okay, its speed is maximum around 7.9 or 8 kilometer per second. Here the G value is very low. So here the orbital speed is what? It's a low, around 3.1 or 3 kilometer per second. Still satellite will be in the orbit, not fall down. Okay, so I think conceptually you people can understand. Okay, I think conceptually you people can understand. Here the speed is maximum because G is maximum. If you will not be maximum speed, so suddenly the satellite will fall down towards Earth. And see one thing more guys, those value I have given you, this value is accurately correct. These all the values are accurately correct. But your examiner never ask you at different distance what should be the orbital speed. If you people have a SC Verma, okay, S.C. Verma book, guys. So in S.C. Verma book, in the gravity and gravitational wala chapter, here some fundamental even is given there. Through the help of it, you people can do the observation at different height. What should be the orbital speed? Okay, but numericals, please don't go as a theory. You remember just concept that when a satellites will be close from the surface, because g is maximum, it can easily fell down to fell down. So this is the reason speed is should be very very fast. Here the gravity value is minimum, so here the orbital speed definitely low. Okay, but still it will be maintained in their own orbit, it will not reach to the ground. This is the general logic here in this case. Okay, you tell me, guys, this entire discussion you people clear or not? And this was the UPSC prelims question, you people understood. Tell me, guys, I want everyone answer as yes sir, I understood. Just tell me, yes sir, I understood. I am waiting your answer here, guys. Okay, this is those part, guys, which are missing. Nobody is even discussing these all the topics. Great. One thing more I'll tell you, guys, those orbit wala part I'm discussing you, here you all people are different from the other institutions students. Okay, because no one is there. I have not seen that any places of people are going to take a classes of the orbits. But geostationary, geosynchronous, polar sun-synchronous, this is the demand of UPSC. Why satellite not fall down to the surface of Earth? This is the demand of UPSC examination in the last 10 years. Okay, so here you people will definitely better from the other institutions. Trust me. Okay, how will it maintain the speed? Actually, when you go in the physics, Shreyas, so it's because of accelerations. In the circular path, there are different acceleration is required, but I did not enter there. As just a simple logic, remember certain orbital speed is required. Okay, fine. Yashwani, what happened when the fuel is over? I am not discussing about the fuel, I am discussing about the orbit. Fuel portion will discuss under the launch vehicles. You just wait. Okay, fine. Now come into the another part. Fine. So it's a entire concept. I discussed why satellite not fall down to the surface of Earth. Now come next. I hope you all people have drawn this entire picture. Okay, fine. Now just listen, guys. One side I am going to discuss with you about the orbits, and second side I am going to mention with you about the different types of satellites. There are again some connections. Again, just like you have seen, guys, like distance wise and the position wise satellites have some connection. Similarly here. Okay, similarly here in this case. What are here? Listen. One side, study of orbit. Okay. So one side I am telling you about the different types of orbits. Official orbit. So orbits. In those orbit where people even generally launch the satellite. So officially orbits. Deepak, your answer I'll give you. Wait. Okay. Wait. Because those discussion already even later on. Okay. So why discuss right now? Okay. But okay, if you ask me, so I'll give you one statement. Like satellites, those we are going put into the orbit. Okay. For its movement, for its revolution into the orbit, there is no need of extra fuel. Neither how Aryabhatta is still in their own orbit today. Even 1975 you launched it. Okay. But it is must, guys, you fix the satellite into the proper orbit. Array, guys, those space scientists, you people know, they have a knowledge of mathematics and physics. They are not like you people. Okay, they have proper scientists, guys. They have done their own, they have given their own life even with the research and all, R&Ds. Okay, even I told you, S.C. Verma, it is mentioned at which height, what should be the orbital speed. So what generally launch vehicle is doing? Launch vehicle carry the satellites and put the satellites, even launch vehicle maintain the proper speed in the orbit and the left the satellite and move away. Now satellite is already fixed into the orbit, have no issue, don't worry. Okay, no any fuel is required when once the satellites put into the orbit. Okay, now satellite is moving. Neither how it is possible from 1975 to till now, 40 years plus over. Okay, how satellites, who will go and provide the fuel after certain year, after certain period of time? Not possible. Okay, so remember, it is not so. Okay, so it's a uniqueness of the space technology. Don't worry, no, not even any fuel is required to keep the satellite into the orbit. Once if satellite put into the orbit, now satellite is moving in there. I hope Deepak, concept wise you clear. How satellite send the signals another, for that purposes some solar panel we are using, but that is a different part, not here. But satellite is not using any extra fuels. So do satellite decelerate. Then what? Then what? Abhinandan, then what? Okay. So you are just telling me, sir, when we people do the deaccelerate, so then we can carry back the satellites toward the ground. See, till now no technology has invented. Neither those space debris or space junk has been created into the space, guys. Why we will generate this space junk? After the completion of lifespan of the satellites, we will definitely carry back towards the ground. Okay, till now have nothing. Even many experiment happen, but that is another part, not have a requirement of UPSC, so I am not doing that. What kind of experiment people have done to solve the space debris or space junk or Kessler syndrome types of problems. This is not my part, guys. Okay, according to your examinations. It is shown in the Mission Mangal movie. Actually, deaccelerate and accelerate wala purpose is not here. That is in some other logic. Okay, what is in some other logic in the Mangalyaan movie, if you people have seen? So that discussion I'll do during the Mangalyaan. You just wait. That example of tawa wala was given there. Okay, tawa was example that used there. If tawa is hot, tawa is that utensils that we are using to make a chapati. Actually, that's it called as a tawa. Okay, so that discussion I'll do in the Mangalyaan, don't worry. Okay, how the PSLV even not have a quality based launch vehicle, but still send the Mangalyaan at the 300-400 lakh kilometer distance. So in that discussion I'll do. Wait. Okay, Diksha, I understood. You come first. Okay, don't ask me more questions. Abhi, you just ask all the questions related to orbits. Okay, I'm so happy that you got the interest and it's so good. Okay. Recently, Chinese satellite fall on the earth in the news. See, not Chinese satellites. In the past 50 years, in my knowledge, around 4 to 5 times these incidents happen. 4 to 5 times these incidents happen. Even thousands of the satellites are there, but in the last 50 years, only 4 or 5 times it happened. It does not mean all satellites will fall down. But this much of negative you people cannot be. Even those examination you are going here, hardly selection will be how much? 700 seats. But the people, those are going to apply around 5 lakhs. Here you people are much confident. Out of 5 lakh, here the case is what? Out of 5 lakh, here the selection is 700, 800 students. You are much more confident. But where have only 1 or 2 case happen, you people are very negative. Ki sir, next of the satellite, those I will launch, it will definitely fell down. How you people can be this much of negative? Even many people ask me, sir, if COVID happens, so I will be no more. So, sir, what is the purpose of study? See, guys, what will happen in the coming future, nobody knows. To make your future better, give your effort this time. Okay, so don't think about what will come in the later on. But here in the case of COVID cases, even not the death rate of 1% proper in India. 1% around something, 1 or 2% around something death rate, if you check it. So hardly 2% death rate may you will come only. You are this much of a special by God ki God will create your life and God will kill you. But how you people can be this much of negative? Please try to understand. And UPSC aspirant should be full of positiveness. This is very, very important. Many people in your surrounding, those are failures. They will demoralize you. But your potential, your inner power, your willpower, your self-confidence will boost up. Hey, this person is failed. That's why the person is telling like it. Because all the people, those even selected, they are not in your surroundings. They are doing their own training and they are enjoying their own life. Only failures, not successfully students, they are in your surroundings. So please keep your confidence. Maintain your confidence and willpower. Okay. And be positive. Atul, don't worry. Yes, I agreed with you. Okay. And not first time the Chinese satellite even fall down. Many other happen, but hardly 4 or 5. If you go on Google, you will get it. Fine. Now come orbits. Okay. See different types of the ones category. I'll tell you about the orbit, and second side the discussion about the different types of satellites. different types of satellite. These satellites we are putting into the orbit. Yeah, in this orbit we are putting these satellites. This is the reason orbit and satellite connection is very, very important, and you must be clear. Okay, come here guys. Orbits. The one orbit is called as a polar orbit. First orbit is called as a polar orbit. Second orbit is called as a polar sun synchronous orbit. Okay, one is the polar orbit, second is the polar sun synchronous orbit. Okay, so one is the polar orbit and second is the polar sun synchronous orbit. Third one is the GPS orbit. Third one is what? This is the GPS orbit. Okay, third one is GPS orbit. Fourth one, geostationary orbit. Geostationary orbit, yeah, better I'll write about geostationary Earth orbit. Geosynchronous orbit. And geosynchronous transfer orbit. This is GEO and this is GTO, right? One more orbit is there, that is called halo orbit, but halo orbit discussion I will not do here. Halo orbit discussion I will do in the case of, okay, in the case of Aditya mission. L1 point, Lagrange point and all discussion I will do there. So the one side you got the name of orbits: polar orbit, polar sun synchronous orbit, GPS orbit, geostationary Earth orbit, geosynchronous orbit, and geosynchronous transfer orbit. Okay, second side, the list of satellites, those satellite India launched. Okay, list of satellite those India launched. Here you come, see one thing guys, 5 types of satellite generally India launched. Okay, 5 types of satellite generally India launched. What are these 5 types of satellite? See, the one that is called experimental satellite. The one is a experimental category, experimental satellite. Second category, this is called as a university satellite. University satellite. Satellite terms I am not writing, it is common with everyone. Just like here orbit, common everywhere. Polar orbit, polar synchronous orbit, GPS orbit. Okay, here similarly satellite terms are common. Third one, remote sensing satellite. Third one is what? Remote sensing satellite. Third one is remote sensing satellite. Fourth one is a Earth observation satellite. Earth observation satellite. And fifth one is the INSAT or GSAT. Right on. Fifth one is the INSAT or GSAT. What is INSAT? Indian satellite. And what is GSAT? Geostationary satellite. So INSAT, Indian satellite. GSAT, geostationary satellite. So INSAT is the Indian satellite and GSAT is what? That is the geostationary satellite. Okay, INSAT Indian satellite and GSAT is the geostationary satellite. Now there is connection. Actually, you know guys, I just have seen in the last year on ISRO site, they remove university satellites. They remove university satellite. But last year on ISRO site, university satellite list was also there. Why they remove, I don't know. But university satellite was also there. Okay, university satellite was also there. Okay, fine. Now listen about the experiment. See, experimental satellite means what? General satellites. Just like Aryabhatta. In the beginning, that was a part of experiment. We wanted to check, guys, that we can be successful or not. Aryabhatta, Bhaskara, Rohini, SROSS, this type of satellite, those India launched in the beginning, it was experimental category. Okay, see one thing I'll tell you, actually experimental and university based satellites are not required for examinations. So experimental and university satellites are not required for examination. You remember first one. Okay, but Aryabhatta, the 19th April 1975, as date and year I have remember, you people also remember because it made a history of India. Okay, and Aryabhatta was under the experimental category, but don't expect any question from here. Okay, there will be no university satellites are what. So even still India is launching and testing many of the satellites, experimental satellites. Okay, definitely on that basis some new coming future missions India launched. So experimental satellite still India is launching. Okay, and Aryabhatta 19 April 1975 those India launched, it was also experimental category. Okay, it was also experimental category, don't be confused. Next point. What about the university satellite? Actually guys, many of the university scholars, students, scientists, professors, they also develop satellites. Okay, and these satellites they provide to the ISRO. ISRO, when you people launch your satellites, so one of satellite you also launch in that orbit just for the experimental purposes. Reason these students, these scholars in the coming future, they become as a scientist in the ISRO and NASA, and government also launch their own satellites for experimental purposes. Okay, generally for university level of students, scholars, they even developing it. I can give you some example like SRM SAT. I can give you example like NUSAT. These are what SRM SAT, NUSAT. These are the example of university satellite. SRM SAT, SRM University Chennai. SRM University Chennai. Okay, that university students has developed a satellite. That's why the SRM SAT is written there. SAT abbreviate as a satellite. SRM is the name of university. NU is what? Annamalai University. NU is representing as Annamalai University, and SAT is what? SAT is a satellite. So Annamalai University satellite. This is Annamalai University. Annamalai University, you know very well, university. Okay, everyone. So in that way, guys, in that way, names are given. In this way, names are given. Okay, in this way, names are given. I hope you people very clear, and no one have any doubt here in this case. Okay, no one should have any kind of doubt here. But again, I repeat, experimental university not required for an examination. Come here, remote sensing, Earth observation, and INSAT as I said. See, INSAT is what? Indian satellite. In represent as a Indian satellite. But the name of INSAT right now has been changed as a geostationary satellite. Why the INSAT has been changed as a GSAT? Under INSAT discussion I will do. Okay, under INSAT. But now come about these satellites we are launching into different orbits. What are it? Generally remote sensing satellites we are putting into the polar orbit and polar sun-synchronous orbit. Remote sensing satellite generally, I am not telling you only. Remote sensing satellite mostly, normally, generally, not only term I am using. Okay, we are putting into the polar sun-synchronous, but mostly polar sun-synchronous is the best place for remote sensing satellites. Okay, so remote sensing satellite we can put into the polar orbit or polar sun-synchronous orbit. Next point. INSAT series or GSAT series satellites we are putting here into the geostationary, geosynchronous or geosynchronous transfer orbit. All these differences I will discuss with you, you just wait. Okay, what about the Earth observation? Earth observation is a miscellaneous case. Earth observation is a miscellaneous case. Earth observation is a miscellaneous case. When Earth observation satellite on one of the mission that is called NISHAR project, I will discuss that time I will explain. But remote sensing you remember into the polar sun-synchronous. INSAT or GSAT you remember geosynchronous and GGT, geosynchronous transfer orbit. PISAT from PSAT Bangalore. Okay, fine. Okay, fine. Agreed. Now come. And we'll start first with the polar and polar sun-synchronous orbit. So now I'm discussing about the orbits first, and later on we'll go into the discussion of satellites. So come into the polar orbit. Now it's an entire concepts. And literally you people enjoy to understand this polar and polar sun-synchronous. Okay. Okay, what I explained there, I just mentioning these satellites into these orbits we are using, that's all. Why satellite into these orbit we are using, that discussion I am doing. Okay, fine. Polar orbit. See guys, what about the distance of polar orbit? LEO. Polar and polar sun synchronous orbit distance is what? LEO, 50 to 2000 kilometer. Okay, see guys. One more point that is very, very important. Okay, one more point that is very, very important. When I have discussed with you, like this is the Earth, this is a satellite orbit. I hope you remember. Okay, I have one more questions. Okay, just you tell me. One side I am telling you distance of satellite, because it left here, and that is very, very important. This logic I'll use some in some discussion. Second side I am telling you orbital speed. Orbital speed. And the third one I am telling you about orbital period. Orbital speed and orbital period. So distance, orbital speed and orbital period. Okay, I am giving you some factual data. Suppose distance is a 50 kilometer. 50 kilometer. And distance is maximum 36,000 kilometer. In between the another ranges, I hope you know very well. Minimum I have taken suppose 50 kilometer, maximum I have taken 36,000 kilometer. What about the speed, orbital speed at 50 kilometer? You people have seen around 7.9 kilometer per second. Around 7.9 kilometer per second. What about 36,000 kilometer? Around 3.1 kilometer per second. As distance is going to increase, so what about the orbital speed was going to decrease. If here satellite is moving, guys, here satellite is moving, so satellite is moving with very faster speed, 7.9 kilometer per second. If satellite is moving here, the satellite speed is around 3.1 kilometer per second. Okay, here satellite is taking around 88 minutes to complete one revolution, because speed is faster and distance is very less. So what about the orbital period, time period? It takes around 88 minutes, something like it, yeah, 90 minutes around. 88 minutes and 90 minutes. And you know, when the satellite is moving here with 3.1 kilometer per second, here more distance and speed is less. Here satellite is taking total 24 hours around. Here satellite is taking total 24 hours around. It means when the distance is going to increase, what about the orbital speed is decreasing? When the distance is going to increase, orbital speed is decreasing, but orbital period duration is going to increase. So here satellite is taking 24 hours. So this point you people also mention on your note, on your copy, guys. This is very, very important. Please note down. And one thing more, guys, you people tell me that entire logic you people clear or not. If you understood, write 1. Not understood, write 2. Repetitions, what is the requirement? Already picture wise I describe you. Okay, so if you people understood, write 1. Because all the entire discussion those I have done, that conclusion I have done here. All the entire discussion conclusion I have done here. Actually, why I am asking you, reason here, downside, have some discussion of geostationary orbit concepts. Okay, geostationary orbit, geostationary Earth orbit. That's why I am asking you. %99.9% means every student has given me one answer. Only one person could not understood. Okay, one person, neither rest of all people has given me one. So excellent, guys, excellent. Only one person told me just two, neither rest of all one. And I think 2 to 3 times I have done all the revisions. I have done all the revisions. So now the next time is not possible. Okay, now next time is not possible. This 24 hours, it's 88 minutes, is 24 hours. Okay, it's a 24 hours. Okay, so this is the entire concept. If distance is less, I describe you in the previous, same thing again, not possible, guys. Okay. And definitely if 90% students are getting and giving the response, so if 10% students have a problem, so problem is your side. If 90% of students have a problem, then problem is from teacher side. Okay, it's my philosophy, I remember. So if one student or two students have a problem, the problem is your side. Neither every student why they will satisfied. Okay, and we am taking your coaching classes, teaching class. Okay, here it's not a tuition, the one-to-one interaction. Majority follow, so the classes is fine. Okay, so it's okay. Come next. Okay. So I was telling you about the polar orbit. Now come. I have given you some logic, and this logic I will discuss with you in the discussion of geostationary Earth orbit. Okay, some of the discussion I'll do through the help of some videos. I'll open here on YouTube videos and I'll show you. Wait guys, you come into the polar orbit first. Polar orbit. Polar orbit is what I hope everybody know very well. Its distance is around 50 kilometer to 2000 kilometer. Because polar orbits are where into the Leo distance. Polar and distance, I hope you people remember, and this height. And this height. 50 kilometer distance, the polar orbit you people know very well, satellite is moving in this direction. Satellite is moving in this direction, revolution, pole to pole, pole to pole, pole to pole. At 50 kilometer distance, satellite is taking how much time? 88 minutes. You just have seen guys. Satellite is taking total 88 minutes because orbital speed is very fast. So suddenly satellite will reach here. Okay, 88 minutes. Okay, fine. Here satellite will take how much duration of time? 24 hours. 3.1 kilometer per second, you remember. Fine, now come. Okay. Even 1 or 30 minutes not happen, but people started to demand of break. How interesting people are here, okay. Matlab the people sit here for the break, not focus for the study. I remember I'll give you 5 minutes break, but still see 8:22 is happen. I started my class 7:02. Okay, 7 around morning. Okay, and it's 1 or 30 minutes. But see some of the students what it show that how much people are literally want your selections. Okay, fine, leave it. Better some of the masses I avoid. Fine. I just wanted to give everyone attention, but I think you people never want I give everyone attention. So whatever you want, everything you are going to write it. If some topic of discussion is going on, it can take support 10 minutes more, but still no sir, timing pay you give a break. Very good. Very good. Okay, fine. How much you are punctual, I don't know. Fine, come here. So polar orbit 50 to 2000 kilometers. See guys. Okay, actually here 50 kilometer, it's take around 80. If I put the satellite at a distance of suppose 1500 kilometer distance, you know at 1500 kilometer distance, satellite is taking around 120 minutes. Roughly, you just imagine 120 minutes. In one revolution, 120 minutes around 2 hours. Definitely, if distance I will increase, the orbital period, orbital speed will be slow and it will take more time because more distance is going to cover. So actually, I'm going to put the satellite here, guys. Okay, I'm going to put the satellite here, guys. Okay, at a distance of 1500 kilometer, and now satellite is taking 2 hours in complete one revolution. Actually, 88 minutes. If you count, it will be difficult. 5 p.m. 6 p.m. is going to happen. After 88 minutes, what will come? Then after 88, what will come? It will be difficult to measure it. That's why I'm putting a satellite in that location where satellite will take 2 hours to complete one revolution. If satellite here at 6 p.m. after one revolution, satellite will reach here at 8 p.m. Again, next revolution, satellite will reach here at 10 p.m. That's why I'm going to put the satellite at a distance of 1500 kilometer in the polar position where satellite will take total 120 minutes or roughly around 2 hours. Okay, around 2 hours. You come here, guys, in this case. Trisha, those questions you are asking that between 2000 to 5000. Okay, and 20,000 to 30,000. Actually, here we are not putting the satellite due to have some inclination angle problem. Yeah, in a very simple manner, I can tell you, it's a disturbances places. Here the satellite could not work properly. Simple answer is this. Okay, simple answer is this. Okay, now come here into the discussion of polar orbit. See. Try to understand the entire concepts. Okay, fine. It's a polar position, everyone know. I just going to put the satellite here. Okay, in the polar position. And India is towards me. Okay, everyone? India is towards me. And the satellite is taking how much? Suppose just this time is 8 o'clock morning. Okay, satellite is going to enter from the south end of India, that is Thiruvananthapuram. Suppose that is a Thiruvananthapuram. The south end of this is Thiruvananthapuram. Okay, at 8 o'clock satellite enter to the Thiruvananthapuram. because satellite is moving in this way, in this way, pole to pole, pole to pole. Suppose at 8 o'clock satellite enter to Tiruvananthapuram, 8 o'clock morning. 8 is here, 8:05 Bangalore, 8:10 Hyderabad, 8:15 it's Nagpur, 8:20 it's around Delhi, 8:25 it's reaching around Shimla, 8:30 it is going to across the Jammu and Kashmir. Suppose it means I'm telling you 8 o'clock enter to India, 8:30 across India. So 30 minutes the satellite is in front of India. Now after this satellite will come to China, Kazakhstan, North Pole. Okay, North Pole, and then what? Some Canada, then North America, this region, then come to the South Pole, oceans, ocean. Then 10 o'clock again come in front of Tiruvananthapuram. I hope you are getting my point. If satellite at the distance of 1500 kilometer at 8 o'clock satellite is here, so after 2 hours different countries, and then coming again at 10 o'clock exactly at in front of Tiruvananthapuram. But actually it is not Tiruvananthapuram. Reason in 2 hours Earth also rotates some angles. So left of Tiruvananthapuram, that is the Lakshadweep, the satellite is going to pass from Lakshadweep, Arabian Sea and some other countries. Tell me, those logic I am telling you, you understood or not? If I put the satellite exactly at 90 degree of polar positions, 90 degree of polar position, so satellite is moving in this direction. If one point I will take and I am measuring the time, this point is here, where the satellite was 8 o'clock. Okay, now the satellite 8 to 8:30 is working for India. Now other pole, other countries, ocean, South Pole, then again it will come in front of India. But after 2 hours, it will not in front of India because Earth rotate in 2 hours. So now at this point, earlier was 8, now this point, and see 8:05, 8:10, 8:15, 9, 9:10, 9:20, 9:39, 10 o'clock again reach at the same point, 10:05, 10:10, 10:12, 30, 10:40, around 12 o'clock again reach at the same point. Rest of the time period, other countries, oceans, North Pole, South Pole, it is going to pass. This logic you clear or not? Okay, so I think everybody is even mentioning me like, sir, one, I understood. They try to understand, guys. The orbit is not cup of tea, and this is the portion those are missing in every institutions. But last 10 times I have seen 3 to 4 times UPSC asked the questions. Today after this class you will not have a single problem. It's my promise. If you have something, because everything is not depend on me. Because somebody, you people know very well, you cannot understand. The reason, physics law, 100% energy transfer is not possible. Some losses always come. So definitely some people have a problem, but majority, please give your 100% attention here. It's not a cup of tea, it's not an information, it's a logic and concept. And UPSC have a demand of this. Okay, fine. So I'm just telling you guys at one point if I'm focusing. So again 10 o'clock here. Again what happened? See this point. Again Earth is going to rotate at 12 noon here. Again at 2 p.m. here. Again 4 p.m. here. Again 6 p.m. here. Earth is rotating 24 hours, one revolution, one rotation of Earth complete. Everybody know this geography. 4 o'clock again here. 6 o'clock evening again here. Okay, rest of the time other countries. 8 o'clock again come here. 10 night again come here. 12 midnight again come here. 2 morning again come here. 4 morning again come here. 6 morning again come here. 8 o'clock again, you know what happened, guys? Again India in front of Tiruvananthapuram. 8 to 8:30 again it will work for India. Actually it is the mathematics. Scientists know very well at how much distance, what will be the orbital speed we should maintain, and for how much duration of time a country will in front of the satellites. Accordingly they set various satellites. Okay, it's a mathematics and physics. You don't go for the mathematics and physics. That scientists know very well at how much distance with how much speed satellite will be there, and for how much duration of time this satellite will work for India or any other country. As India is going to launch their own polar satellites, similarly other countries are also going to launch their own satellites. Okay, so in that way we are going to launch the polar satellites. Now you can ask me one question, sir, what is the purpose of these satellites? This satellite according to you hardly work for 30 minutes. Hardly work for 30 minutes. Then what happened? If only work for 30 minutes, suppose, or 20 minutes, suppose. So in 24 hours, as those explanation I have done, in this explanation you got, in 24 hours, this satellite is in front of India only for 30 minutes. Okay, I agreed. In 30 minutes, at least it will take a picture and images of the Earth or not? At least 30 minutes it will take the picture and images of the Earth or not? Yes, 30 minutes at least it will take. So it will pass from very close to the Earth's surface. See, the distance of it was distance of 1500 kilometer. So 1500 is going to pass very close from the Earth's surface. So very close from the Earth's surface. So properly was the Earth picture and images. If you want to do earth mapping, if you people want to do earth mapping, so polar satellite is the best satellite for earth mapping, for disaster monitoring, for flood monitoring. But it's an example of disaster, I'm telling you guys. Somewhere some casualty happened, you want to measure flood prone areas. Only for 30 minutes, but you can check properly, guys, because satellites are getting close from you people, guys. Building and monuments, you can check. How much the areas, urban planning you can do proper, guys. This side the road have a lot of rush because it's a bottleneck type of roads. So massive rush is there. Okay, so you can check through the help of satellites. Okay, even guys, North Pole and the South Pole picture you people can take. Melting of ice. Okay, weathers or any changes are going to happen, suddenly satellite can monitor everything. And a part of this, guys, after 30 minutes satellite is going to pass from other countries. So you people can also do spy of other countries through the help of remote sensing satellites. Here you people may have a question. So sir, if I'll do spy of any other country, so any other country cannot oppose. Why oppose? Other countries' satellites are also coming across your India, across your nation. Okay, if you have a technology, you do spy. But you are India. You have a need of which country to spy? Sir, no need of any country spy. So you don't do it. I hope you understood. But yes, it is also possible. Weather forecasting you can do because satellites are very close from the surface. What about the pressure differences and all going to maintain? Okay, fine, in 30 minutes, but in 30 minutes you can check it. Even pollution level you can check, guys. Chlorophyll content to the plant you can check. But only for 30 minutes. If I'll ask you one question, guys. If you want to use the polar satellites, what? Remote sensing. I told you guys, remote sensing satellite, just I told you, satellites in the orbit. Where we put? The remote sensing satellite we put into the polar orbit of polar sun synchronous orbit. So those function of polar orbit, I am telling you, these all the entire function of remote sensing satellites. Because which satellites are actually into the polar orbit? Remote sensing. The entire function of polar orbit is the entire function of remote sensing satellites. So listen, how beautiful feature of satellite have because of the putting into the certain orbits. So satellites work. Why? Because satellites put into the proper orbits and then satellites become specific. I think Swikriti, you did not see the movie Parmanu. If you will see the Parmanu, you will get it. Okay, you will get it. That's some discussion I'll do later on, not right now. First of all, my attention is your questions later on. First, you listen my topic, those I'm telling you. Okay, because you started to understand, so you probably started to ask me many questions. But that question is not relevant for UPSC. I'll give you your answer in the last. But I hope you people very clear. The function of polar orbit is what? Remote sensing satellites. But one thing, guys, in the case of polar orbit, one problem is there. And that problem you must be clear, which is very, very important. In the case of, again I'm repeating, in the case of polar orbit, one problem is there. What about the problem is there? Listen. Okay, what about problem is there? Listen. Suppose this is Earth. Suppose this is Earth. Okay, suppose this is Earth. Okay. This is what? This is equator. This is equator. Okay, fine. This is equator. Now come. This is equator. Okay, see. Suppose this is India. Suppose this is a high-rise building. This is a high-rise building. Okay, in Bangalore. There is a low-rise building in Bangalore. High-rise building and low-rise building. So Bangalore high-rise building and the low-rise building. Okay, so in Bangalore, this is one is the high-rise building and second is the low-rise building. So high-rise and low-rise building. Now come. What will come here in this case? High-rise building and low-rise building. See, satellite is here. Okay, and suppose sun is here. Oh, so this small cap is a satellite. Okay, and this mouse is, suppose it's a sun. Okay, the small cap is a satellite and the mouse is sun. Okay, mouse is sun. See guys, actually you know what happened? Satellite is moving in this direction, pole to pole, pole to pole, pole to pole. Okay, and sun is here. If sun is here, satellite is here, all are in one line. All are in one line. So you know, proper satellite will take a picture of images, picture and images of the Earth's surface. If building and monuments is this one, building and monument in this one, so the picture and images will provide that building and monument is here. But you know guys, what happened? After some time, the sun will come here. I know very well sun never move. Okay, in the respect of earth. Earth revolve the sun. But we people feel that sun is going to shift here. Why? Because we people are on the earth's surface. So as you people are feeling, you just try to think it. What is going to be happen after some time? Sun is going to shift here because of earth is going to shift here. I hope you are getting my point. I'm telling you, when the sun and the satellite all are in one plane, no picture, no problem is there. Because what about the building and images are there? Perfect images will come. But after some time, you know, satellite is moving. After some time, sun will come here. After some time, sun will shift here. After some time, sun will shift here. After some time, sun will shift here. When the sun will shift here, but still satellite at 90 degree, what will come? Now this building will have a shadow. Now this building will have a shadow. Because sun is shifting here. When the sun is here, this shadow will come. And because of this shadow, when the satellite, if satellite is still at 90 degree, so satellite will see the building images is this, building images is this. This is the wrong image. This is the wrong image. I hope you understood. And this is the problem in the case of mapping when you put a satellite at 90 degree. Because sun location is not same. Okay, sun location in the respect of satellite is going to change every moment of time. Neither you just have to wait. When the sun and satellite both will come together in one place, then the picture images you take. Up, see guys, how much difficulty you will have. Only for 1 minute, only for 2 minutes, yeah, 30 seconds, better picture and images will come. Neither rest of the time period have a shadow and all. So to solve out this problem, ultimately 90 degree base satellites, it's not fine. We people have done some modification as a name of polar sun synchronous orbit. So polar sun synchronous orbit was required to solve out this problem. Because at 90 degree polar orbit was not working properly. So now question is, sir, what will come into the case of polar sun synchronous? Actually, there are many satellites, America, India, many countries even sent into the polar sun synchronous place. That one of the example I'll tell you. One of the example of polar sun synchronous, listen, at 798 kilometer distance from the Earth's surface, 98.6 degree inclination. 98.6 degree inclination angle. Okay, if you put a satellite, this satellite nature will be polar sun synchronous. Actually, one of the US satellites in this place, at this place, as a polar sun synchronous. Some other distance, some other inclination angle, again it can be a polar sun synchronous. Again some other distance, some other inclination angle, again can be a polar sun synchronous. Again can be a polar sun synchronous. Definitely you people will ask me, sir, I am still not very clear how now the problem is solved because of this distance and in this angle. You just tell me guys. Okay, Mano, your question is very bachon type wala questions. So your bachon type wala answer I will give you at the last. Okay, you just wait. Because everybody, those questions they are asking, these all are the bachon type wala questions. The problem is you did not listen me in this entire session. Okay, so again you people have a keep patience. Okay, many satellites are there, collision happen. Many students are sitting in the chair in the class. You people do the collision. No sir, no. Why? Because the satellite's position is also same as like the class have a seat positions. Okay, you tell me with on one seat two people sit together. No, because one seat already fill up. The next now the seat is not vacant. If any student will come, then any student will sit to the next place. So accordingly, every country those are launching the satellites, they are providing the data that on this orbit I have sent the satellites. The rest of the orbit is free. The people are sending to the rest of the orbits. Okay, and upside the space is very big. So there is massive orbits. Even for next 50 years, if you launch the satellite, still the satellite orbit will not fill up. It's not a strength in the class. If 150 seats are there, only 150 students sit. But upside in the space, millions of the satellite you can put. There is a many space are there. Don't worry. Okay, and the country-wise, every countries are providing the data that my satellite is here, and the worldwide every countries know. Internet, online, they know, and they accordingly never launch in that place where the satellite already launched. And many of the millions of the satellite places still left into the space, guys. So another places people use and put the satellites. But you focus here about the polar sun synchronous. Okay, you just focus here the polar sun synchronous. Actually, what is the problem in the case of polar orbit? You listen, guys. Okay, the problem you people understood about the sun rotation, sun directions. I'm giving you observation. You know what is the difference between the 90 degree and 98.6? 90 degree means if satellite is moving from this point, so after revolution, satellite will again meet at the same point. But what is the meaning of 98.6? 98.6 means when the satellite is going to complete one revolution, satellite will come ahead from the initial point. If initially satellite is here, now satellite move here. After the next revolution, satellite will come here again ahead from the previous location. Again 98.6 again ahead from the previous location. So what actually going to happen? At 98.6 degree, around 98 degree, what is going to be happen? Satellite not meet at the same point. After one revolution, satellite will ahead from the previous point. After one revolution, satellite will ahead from the previous point. After one revolution, satellite will ahead from the previous point. After one revolution, satellite will ahead from the previous point. In this way, satellites are moving. And what is going on with the sun, guys? Sun also going to shift, sun also going to shift, sun also going to shift, sun also going to shift. So every moment of time, you just imagine, guys, you just imagine. You just imagine. This is the earth. This is the earth. Okay. This is what? This is satellite. This is satellite. This is satellite. And what is it? This is sun. Okay, fine. What is this? My thobda is what? My face is what? That is what? That you imagine? This is the earth. This is the earth. Okay. This is a high-rise building. This is a high-rise. My nose is a high-rise building. Okay, fine. This is the satellite and this is the sun. Okay, when satellite and sun all are in one plane, and now satellite will take the picture images, the proper building is there. But after some time, what happens? Sun will come here. When sun will come here, still satellites in 90 degree. What happened? This building shadow will come. And now the satellite will think so. Satellite images will provide that this building images is up to here, even shadow also. That is a wrong. This one I discussed in the earlier, guys. Now how the problem will solve out? In the 90 degree, this is the condition. But in 98 degree, what will come? In 98 degree, when the satellites is going to revolve like this, revolve like this, revolve like this, revolve like this, revolve like this. Now satellite will again come in front of sun, because it's not 90 again it will come there, 98 it will come here ahead from the earlier point. Then again after some time 98.6 again come here in front of sun. Again after one revolution again satellite will come in front of sun. Again in the next revolution again come in front of sun. Either it's India and other countries, it's a Thailand or some other country, it's a Japan or some other countries. No picture and shadow will come, because now the satellites again coming in front of sun. So any countries are going to pass in front of satellite. Now 100% picture and images without shadow will come. So what you got in this 98.6 degree inclination and in this 798 kilometer height from the surface, every moment of time satellite follow path of sun, satellite follow path of sun. As sun is going to shift, satellite is going to shift. As sun is going to shift, satellite is going to shift. And that is the reason it is called as a polar sun synchronous orbit. How mathematics and physics scientists apply, but in your paper this technically you don't go what is the distance, what is the inclination. You just remember this is the orbit where it is looking like every moment of time satellite follow path of sun, satellite follow path of sun, satellite follow path of sun. So if any country's images are pictures, satellite is taking, any country's picture images satellite are taking, any country's picture and images satellite are taking, so there is no images, no shadow there. You people tell me, sir, I understood. Don't write 1, 2, 3. Sir, I understood. If any country's picture and images it will take, it will be better. Sir, I understood. I want your answer. Sir, I understood. I want you people connect with me, please. I want everyone answer. Sir, I understood. And in the support of it, I'll show you one video also. Don't worry. Excellent, guys. Excellent, guys. Everybody told me, sir, I understood. I'm not going to force you guys. Sometime I show my expression something looking very horrible type, because everything is required in this study, guys. Even your parents also doing the same. Sometimes they are showing anger, but they love you most. They care you. That's why I also do something. Okay, sometimes I show very anger. Okay, that I'm very angry on you, but I also love you, I also care you. So it's a part, just like your parents. I'm also working here in front of you inside the class. Great, guys. Okay, see one thing more. So what is the polar sun synchronous? So polar sun synchronous, you write polar sun synchronous, right? At this position, right? At this, here I'll dictate some point, because it's a very important question for your coming year. At this position, it is looking like at this position, it is looking like that every moment of time, at this position, it is looking like that every moment of time, satellites follow path of sun. Every moment of time, satellite follow path of sun. Okay, in this position, it is looking like that every moment of time, satellite follow path of sun. So this is the reason it is called in polar position. In the respect of sun, this orbit form polar sun synchronous orbit. Synchronous means in the reference of sun. Together, this is what, even whenever I'll show you a video, this considerably much more clear. And see one thing more, guys, there are many polar sun synchronous orbits is possible. Even one of the example I have given you, because inside the book this example is written. One of the US based polar sun synchronous orbit, height was this and angle was this. Similarly, I can tell you, suppose the distance I am going to change 850 kilometer, maybe 97.3 degree inclination, again polar sun synchronous orbit form. Okay, maybe I am going to put the satellite at 778 kilometer. Okay, and the distance is suppose 99.2 degree inclination, again have a polar sun synchronous. But concept part is required, not the factual data. Okay, you are not a space scientist, and UPSC will never ask you at what about the distance, what should be inclination angle to keep a satellite as a polar sun synchronous. Please, as simple logically you people remember what is the polar sun synchronous. Last I'll show you one video and then I'll give you a break, and after break I'll come into the discussion of geostationary and geosynchronous. Okay, come here. Polar sun synchronous. Actually, I am not getting those video. I got it on YouTube. Let me check. Give me 1 minute, please. Where is that videos? Let me see. It was a 1 minute some second videos. क्या हो रहा है यार, ऐसा तो पहली बार हो रहा है, मिल ही नहीं रहा है. So better you take a break. After break I'll show you. Okay, better you take a break. After break I'll show you. At least I will search in between. Okay. Please include some keywords, sir. It was from NASA, Harvard, etc. The distance of certain inclinations are related. Are they inversely proportional? Arey, just a theory you remember. Okay. Displacement of satellite position not clear. हाँ तो you just remember the concepts. Okay. Practically is not possible to understand. Okay. Theoretically try to understand. Neither you come with a SC Verma and start to solve the IIT wala numerical. Okay. You waste your time and waste my time. Okay. I'm not taking IITs and medical entrance examinations. Yeah, I got it. Actually, here in this video, I'll show you actually what is going to happen. Okay. So please have my doubt not the right way. And I'm telling you, okay, it's a not right way. When I said you wait, so you wait. If you don't have a patience, so better you leave my class. I told you I want to listen everyone, but the somebodies have no patience, so please go away from my class. I'm not forcing you. And I don't like to be a best teacher in this world, okay? But those people have a patience and they can follow me, better you listen me. Others you move away. What is the way as you are writing? Sir, please have my doubt, not the way, not the right way. Okay, matlab you people have not the manner to how to talk your teachers and others. So maybe you are also talking still like to your fathers and other one. If I'm avoiding, there are some reasons, okay? I just said wait, patience. I did not say that my subject is over. I'm searching some videos, you started to say this is. Many of the answers sometime I avoid because I know after some time this will come. If I'll take each and every one answer, the 140, 50 students are there, okay? Okay. And I have given you my number also. You can put the message also there. Many options I have given you, but still have no patience. If no patience, so don't come here. Okay. I'm searching one video. I'm here. I just want to do something better and better with you. But somebody have no patience. If not have a possibility to give answer here, so you put on the Telegram, I'll message you. If it is a relevant questions. Okay. Keep cool, guys. Keep cool. Okay. Now come here. It's a polar sun synchronous orbit. Fine. Patience है नहीं आज की जनरेशन के पास. Even I am trying to give every answers, but still no patience. See guys, it's Earth. You see what you will see in this video. It's entire Earth. When I will play this video now, you will get something here going to happen. What is going to be happen? Earth will rotate on their own axis. This point, you just remember this is sun. This is sun, you always remember. This is sun. Okay, and this purple color is showing a orbit. This purple color is showing a orbit. Where the satellite is moving, means revolving. Okay, and this is the satellites. This is the satellites. This is a satellite one. Okay, when I will play this video, what you will see in that video, you know guys, this sun is going to shift here. Actually, again I'm repeating, sun is not going to shift, but it is looking like that the sun is going to shift. It is looking like that the sun is going to shift, but I'm telling you sun is not going to shift. Okay, but it is looking like that sun is going to shift because we are on the Earth's surface. This is the logic. Okay, this is the logic. Okay, next you come. And the satellite is revolving like this. Okay, one thing more. Now sun is going to shift and still the satellite will turn. Okay, see how smartly it is because the satellite is actually into the sun synchronous polar orbit. Okay, this video is available on YouTube, guys. It's animations. Okay, it's animation. You listen. Okay, now listen here, guys. I'm going to play this video. Okay, I'm going to play this video. See what is going to be happen. See, sun is going to shift here, and the satellite also turn towards it. See guys, see, I pause it. Earlier when the sun was here, satellite was moving like this. When the sun is shifting, her satellite's turning, satellite turning. So every moment of time, satellite follow path of sun, And one thing more, guys, if sun is here, so this side have a light and back side have a night. Front side have a day type and the back side have a night type. Okay, sun is here, so light is here and back side have dark. If a satellite is taking 2 hours in complete one revolution, try to understand. If satellite is taking, I'm giving you one more objective question which is very, very important. If satellite is taking 2 hours in complete one revolutions, so 1 hour satellite is in front of sun and another hour satellite is back side of sun. I hope you agreed. 1 hour satellite is front side of sun and second hour satellite is back side of sun. It means if I will put you people on satellites, So you people will find on satellites 1 hour day, 1 hour night, 1 hour day, 1 hour night. Because satellite is 1 hour. If satellite is taking 2 hours, so satellite is 1 hour in front of sun and another 1 hour backside of sun. So if I'll put you people on the satellite, practically is not possible, but theoretically you imagine on satellites what found? Satellite found 1 hour day, 1 hour night. And this is the reason, guys. And why satellite found 1 hour day and 1 hour night? Because of this orbit. And this is the reason this sun synchronous polar orbit or polar sun synchronous orbit is also called as a dawn and dusk orbit. This is also called as dawn and dusk orbit. Dawn and dusk orbit. What is the meaning of dawn and dusk orbit? Early morning and late evening. This is called as a dawn and dusk. Early morning and late evening, this is called as a dawn and dusk. So this satellite will find out what? Dawn and dusk orbit. Means 1 hour day and 1 hour night. So if UPSC asks you which orbit is called dawn and dusk, so your answer is a polar sun synchronous orbit. And now you people very clear why it is so. Now tell me, guys, through the help of these videos, animations, you people understood or not? Okay, dawn and dusk orbit. One more logic I have given you regarding the polar sun synchronous. It is a UPSC standard, you people remember. Okay, it is a UPSC standard, you people remember. Now come. Okay, I'll play this video. And now I just want everyone answer as yes. Again, Deepak, especially you. Your answer, don't worry, I will give you, but keep patience. If I'm not giving you, at last you tell me, I will call you personally. Don't worry. Okay, I'll call you personally. I already here to connect with everyone. Okay, you see, guys, now what is going to be happen? Okay, now the sun is going shift here and satellite is again turning. You see, guys, every moment satellite follow path of sun, satellite follow path of sun. Okay, AGI, this on this animations, this is available. You people can see. Great. Now I'm very sure polar sun synchronous. So polar sun, see guys, see. Now the sun is here and this side have a day. Now the sun is here, this side have a day. Okay, this side have a day. So it's everything, I finished it. Nothing more required in this case. Okay, so I'm leaving this video right now. And now still have some more orbit, those left, and discussion I'll do. Okay. Displacement, you people tell me how displacement of satellite position happen. Reason, answer is what? 98.6. The satellite is not at 90 degree. I hope you people understood. Okay, how just change of 8 degree let the wandering of position. I told you guys how the 8 degree is changing the wandering of positions. That video will show you in these animations. And the next part, after all, it's just change in the angles. I hope you understood how after all it's just change the angles, how the entire system is working. I hope those questions Deepak asked, everybody can see here on chat, and you people very clear with the help of these animation videos. You just tell me you people clear with all the information through the help of these videos or not. Actually, my problem is that I want to clarify everyone in front of it. I don't like to avoid the people here. Okay. You people tell me, guys, those questions even Deepak asked here, that everything in this video it clear or not. If clear, tell me one. I told you just keep a patience. Everything will show on the picture, and now it is complete. If you people have questions, so here I will be responsible. So how is smartly scientists are putting the satellite into the orbit? You people very great, guys. Everybody is responding me. Excellent. So those people have a problem like how satellite is working, in inclination, what is the meaning of 98.6, everything very clear in this farmer picture. How is smartly satellite is working, every moment of time follow path of sun, follow path of sun. Same geographical location will not work 24/7, and that is the reason remote sensing a polar nature of satellite not work for any location 24/7. And here I'll tell you guys, this is the reason polar nature of satellite not work for DTH, not work for internet, not work for satellite news gathering, not work for mobile phone connections, not used for satellite news gathering, broadcasting. Here you must have to use a satellite that will work for any country 24/7. So this type of purpose, this remote sensing a polar nature of satellite never solve. So polar nature of satellite solve those type of information where the satellites require very close from the surface. Okay, only for 30 minutes it's okay, only for 20 minutes it's okay. Here the satellite not for 24 into 7. This is the reason for information communication technology, for television, for internet, polar orbit या remote sensing satellite will not be effective. Devanshu, what is the second name of PSSO? अरे बच्चा, either you call polar sun synchronous orbit or sun synchronous polar orbit, both are same. ऐसे पकड़ो या ऐसे पकड़ो, okay, both are same. Okay, polar sun synchronous orbit, sun synchronous polar orbit, both are right. Okay, Deepak, excellent. तो wait बच्चा, okay, I told you ना, तो you wait. अब finished, come here. Okay. Now come into the another discussion. This is geostationary orbit. Geostationary Earth orbit. Okay, just clear. That is I'm telling you about GEO. You just remember. My question is, guys, what about the position of GEO? What about the position of GEO? So you people know very well, distance wise GEO is what? So distance wise GEO at a distance of 36,000 kilometer. GEO distance was what? At 36,000 kilometer distance approx from the Earth's surface. And position lie plane of equator. Lie plane of equator. Lie plane of equator. Okay, it lies plane of equator. Okay, how it will come? You just see here, guys. This is the Earth. This is the Earth. You can see this Earth, guys. Okay. Now satellite is here. In the case of geostationary Earth orbit, try to understand. Just lie plane of equator. Equator is this. I hope you can see this globe, guys. Equator is here. Okay. Now see, the equator is here. Okay. Exactly from the equator at 36,000 kilometer distance, I am going to put the satellites. Okay. And here at 36,000 kilometer distance, how much time satellite take to complete one revolution? You know very well, 3.1 kilometer per second. Here satellite is moving, revolving. And how much time satellite is taking? Yeah, you people know very well, 24 hours satellites are taking. That's why I have given you one chart. Okay, and now you tell me, guys, I just put a satellite. Suppose this is the axis, and this is the satellite. Okay, so this is the axis. So see, like, and India is here. India is here. Okay, I just put a satellite for India, 24 into 7. So what I'll do, just perpendicular to equator, exactly lie plane of equator at distance of 36,000 kilometer. I just put the satellite here. India is here. Okay, and its inclination angle is for India. So its inclination angle means it's bent towards the Indian directions. If I want to put the satellite for Japan, so Japan is here. You people know Japan is here. So from plane of equator, 36,000 kilometer distance, satellite is here. But inclination angle it focused towards the Japan. If I want to put the satellite towards the Australia, so what the plane of equator is this? From the plane of equator, 36,000 kilometer distance, but inclination angle is downward toward Australia side. In that way, we are putting and setting the satellites in geostationary Earth orbit. Okay, see guys, what will come there? What will come there? You see, up here what happened? Here what happened? I put the satellite at 36,000 kilometer distance, and I'm going to put the geostationary Earth orbit for India. Satellite for India. What is here, guys? Now the satellite and these locations. Satellite is revolving. Satellite is revolving with 3.1 kilometer per second speed. And Earth is also rotating. Here satellite is taking 24 hours in one revolution, and Earth is taking 24 hours in one rotations. So this position and this position always fixed, always look like fixed. This position and this position always look like fixed. So 24 into 7, what you are finding here, guys, you people find out, let the Earth and satellites always look like stationary. But you people know very well, neither Earth stationary nor satellite is stationary. But a person on the Earth, this person will found the satellite is look like stationary, but neither Earth is stationary nor satellite is stationary. But due to this position, okay, satellites revolution and Earth rotation, both time period same, 24 hours and 24 hours. That's why this orbit is called as a geostationary Earth orbit. How beautiful orbit it is. And here a single satellite will work for any countries 24 into 7. Either you set the satellite for India, yeah, you put this satellite for Japan, yeah, you put this satellite for US, for any countries. This satellite will work for 24 into 7. This type of satellite used for communication information. 24 into 7, those type of facility you want, but remote sensing and polar cannot work in that cases. This satellite distance is very high, 36,000. So only to send a signal it is good, but not better to take the picture and images. For picture and images, those satellite will come very close from the surface, like polar and the remote sensing. It will be better in that case. I hope you people very clear. If you want to use navigation, so navigation through polar or remote sensing satellite is possible? No, not possible. If you want to do spy purposes, so geostationary is possible for spy? No sir. If for apne country ke liye, for own country, why you will do the spy? I hope you people very clear. In some cases, remote sensing a polar satellite will be beneficial. In other cases, geostationary orbit satellite will be beneficial. Okay, those DTH connection you people are going to see from satellites to your ground-based station. Okay, those internet, satellite-based internet services we are going to take. Okay, here the satellites are generally what? Here the satellites are generally geostationary Earth orbit. Okay, everyone, this is the entire discussion, those I have done, but still some discussions are left right now about geostationary Earth orbit. I hope you people clear. What is the geostationary Earth orbit? Right? Geostationary Earth orbit. Here at a distance of 36,000 kilometer. Okay. At a distance of 36,000 kilometer. At a distance of 36,000 kilometer with approx 3.1 kilometer per second, with 3.1 kilometer per second orbital speed. 3.1 kilometer orbital speed. 3.1 kilometer orbital speed. Okay. Orbital speed. Satellite look like stationary in the respect of particular location of Earth. Satellite looks like stationary. Satellite look like stationary. Satellite look like stationary in the respect of particular location of Earth. Satellite look like stationary in the respect of particular location of Earth. So satellite look like stationary in the respect of particular location of Earth. Particular location of Earth. Okay, everyone. So Earth rotation and satellite revolution, both timing same as 24 hours. So Earth rotation and satellite revolutionary time both are same as 24 hours. Okay, here Earth rotation and satellite revolutions, both timing same as 24 hours. Both timing same as 24 hours. You people remember as 24 hours. Now you come guys, some more discussion which is very important. I'm entering into some more advanced level, and now final discussion about geosynchronous transfer and geostationary Earth orbit. And now then this discussion will over, and still one more discussion I'll discuss with you about the GPS orbit. Okay, fine. So today entire discussion will be only orbit based. Fine. Come here. Geosynchronous orbit. And geostationary Earth orbit. So geosynchronous orbit and geostationary Earth orbit. Come here guys. Geosynchronous orbit and geostationary Earth orbit. Okay, geosynchronous orbit and geostationary Earth orbit. So geosynchronous and geostationary Earth orbit. See guys. First of all, I'll give you some factual data. Okay, and then at last I will clarify entire concepts. You come here, geosynchronous and geostationary. Actually, geosynchronous orbit, it takes total 24 hours. It takes 24 hours. The complete time period in one revolution in this orbit take 24 hours. And similarly guys, geostationary Earth orbit also take 24 hours. Also take 24 hours. Okay, 24 hours. Fine. Next point. Geosynchronous orbit. Here satellite can move west to east direction and even also move in east to west direction. So satellites can go in west to east direction, even also move in east to west direction. Second point. Okay, but in the case of geostationary orbit, satellite always move in west to east direction. Satellite always move in the west to east direction. Okay, second point. Third point. In the case of geosynchronous, here the satellite can move in the circular to elliptical orbit. Here circular to elliptical orbit possible. Elliptical orbit. But what about in the case of geostationary Earth orbit? Here satellite will be in the circular orbit. Geostationary Earth orbit, here the condition apply, it is only in the circular orbit. Okay, next point. Next point. Here distance of satellite in the case of geosynchronous 36,000 km from the Earth surface, plus minus 5,000 to 6,000 km is possible. Plus minus 5,000 to 6,000. But what about the geostationary Earth? Here the distance is around 36,000 km from the Earth surface. 36,000 km from the Earth surface. Okay, 36,000 km from the Earth surface. 36,000 km from the Earth surface. 36,000 km distance from the Earth surface. So it's a difference between the geosynchronous and geostationary. Okay, geosynchronous and geostationary. So remember, geosynchronous and geostationary. Okay, those I mentioned here, everybody wrote down. Okay, now come. Actually, one of the question UPSC has, those I want to discuss with you. Okay, it's given in the page number. Just see this. Chapter number, I think it's 5. Let me check just a minute and see. No guys, it's a 6. Sorry, it's a 6. And here I'll show you one question. It is UPSC questions, and I just want to discuss here because it's very definitely decent questions. Okay, that question is 6.15, page number 6.15. Okay, page number 6.15. Page number 6.15. Okay, page number 6.15. See the question number 2. Okay, question number 2. This is the question number of 2011 prelims. Okay, UPSC asked the question. I'm expecting answer from all of you. Okay, satellite used for telecommunication relay. Telecommunication, television, broadcasting, this type of things. Relay are kept in the geostationary orbit. So you know very well, definitely geostationary orbit used for this purposes. Okay, a satellite is said to be in such an orbit when? A satellite is said to be in such an orbit when? Okay, now question is, a satellite is said to be in such an orbit when? Okay, UPSC prelims 2011. 1. The orbit is geosynchronous. 2nd, the orbit is circular. 3rd, the orbit lies plane of Earth equator. 4th, the orbit is at an altitude of 22,236 kilometer. Okay, 22,236 kilometer. Okay, I don't know you people can see this question or not. This is mentioned in this page number. So when you people say the satellite is into the geostationary orbit, see one thing guys, this satellite is geosynchronous or not? Geostationary satellite is geosynchronous or not, the first statement. Okay, if you people have a common sense, so you can guess very easily that geostationary or geosynchronous or not. Let me check. Okay, let me check guys. This feature is here, yes. 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 So geostationary is a geosynchronous, I proved. You apply your brain, guys. It's a demand of UPSC. Okay, why I'm discussing like this? This will be proved through the help of your question papers. Some aspect already UPSC has. Other aspect those left in the coming years. This is the reason whatever I am taking in this classes, guys, questions are coming from it, because your examiner has a thinking like it, and I just like to clarify your all the concept according to examiner's need. And this is the reason maximum questions you are getting directly. Okay, that topic somehow it's connecting with it. It means your examiner wanted that you people should know that geostationary orbit is a geosynchronous. I hope you people very clear. Yes sir, geostationary Earth orbit is a geosynchronous orbit. But if I ask you all geosynchronous orbit is a geostationary, so you people say no, because this option is not here, this option is not here, this option is not here. Okay, so I hope so everybody agreed that geostationary is a geosynchronous, but all geosynchronous is not geostationary. Okay, fine. And you must be clear, guys. What is the earth rotation? Earth rotation is west to east direction. If you want to fix a particular location on the earth, so the satellite direction should also be in the direction of what? Rotation of earth. Satellite direction will also be in the respect of rotation of earth. In the respect of rotation of earth. Neither it is not possible, guys, the location can be fixed. If earth is rotating in this way, satellite in this way, so how location can be fixed? So I hope you people have a common sense and you can guess it. Definitely sir, satellite revolution always in the respect of rotation of earth. So the same west to east, what is the earth rotation? I hope you know very well. Earth rotate in west to east direction. So satellite revolution also be west to east direction if you want to fix a particular location 24/7. Okay, this is logic. Okay, this is the logic you people remember. Okay, fine. So one thing more, guys. Okay, definitely you people can ask me, sir, why it is. That other discussion I will do in the case of geosynchronous transfer orbit. Actually, guys, geosynchronous orbit have many types. The one is a geostationary earth and another is a geosynchronous transfer orbit. And that all the discussion I will do slowly and gradually. But I hope you can connect geostationary earth orbit, geo orbit is what? Geosynchronous. But all geosynchronous is not geostationary earth orbit. Okay, one thing more I'll tell you which is very, very important. How you will describe the geostationary and geosynchronous. It's a way through that you can connect relation, similarity and dissimilarities, similarities and differences between geosynchronous and geostationary. In this way you can understand. But how to describe geosynchronous and geostationary? You listen, guys. This is very, very important. Geostationary always is the location is specific. Okay, every moment of time satellite will fix for the particular site. So every moment of time satellite fix for the particular location of time. I hope you can understand. But what about here in the case of geosynchronous? It is a time specific. Time is specific. Time specific means what? If satellite is coming in front of any place at 8 p.m. Okay, at other place at 9 p.m. So again at 8 p.m. at the same place and again at 9 p.m. on the another place, every day satellite will reach there. So it is the time is specific and it is the position is specific. Location better you use a term, position is specific. Okay, location is specific. Position is specific. If you made a fixed position, so always the position is fixed. But here position in the respect of time change. But when the time change, again the same position will come. In that way geosynchronous is defined. Maybe you have a difficulty to understand it, but try to understand. It is my way. In my way I describe the geostationary earth orbit, similarity and differences, so you people can see on the basis of it. Okay, all geostationary are geosynchronous, you know very well. Okay, all geostationary are geosynchronous, but all geosynchronous is not geostationary. You people also know very well. And now I am clarifying you, geostationary always in the respect of position important. And geosynchronous always in the respect of position with time is important. Here position and every moment of time, places are same. But here the same position, okay, in the same time will come. Okay, how it will come, I will clarify slowly and gradually. Okay, wait. But first, as a key point to remember, geostationary Earth orbit, position is specific. Geosynchronous orbit, its time is specific. Okay, it's a time is specific. Now come here. Actually, I'll discuss with you about the GEO and GTO. This is very, very important. Geostationary Earth orbit and geosynchronous transfer orbit. And here I will clarify. Okay, here I will clarify. And here I'll give you one example of IRNSS. I will give you one example of IRNSS. IRNSS is one of the original GPS of India. Again I repeat, I am not discussing GPS this time. With the help of IRNSS, I want to discuss GEO and GTO. I am discussing orbit. Actually, in the case of IRNSS, its full name is Indian Regional Navigation Satellite System. Indian Regional Navigation Satellite System, IRNSS. Okay, this is one of the regional GPS of India. You know one thing. In this case of regional GPS, total 7 constellation of satellites are working. So 7 satellites we installed together, and all 7 satellites are going to take a picture images of India. So 7 constellations of satellites are working together. Okay, 7 constellation of satellites. In these 7 constellation of satellite, 3 into the GEO orbit and 4 into the GTO orbit. 3 into the GEO orbit and 4 into the GTO orbit. So 3 into the GEO orbit and 4 into the GTO orbit. And now through the help of 7 constellation of satellites. Okay, now through the help of 7 constellation of satellite, now the entire Earth images are going to clear. Okay, suppose guys, this is India, this is India, this is India. Through the help of 7 constellation of satellites, now the entire India is going to cover, and across the India's border up to 1500 kilometer you can watch properly through the help of 7 constellation of satellites. In first day lecture, I told you about IRNSS. Okay, during the Kargil war, India had not this type of satellites. Even India was a demand of US based GPS system, now STAR, but US refused it. But today you have a regional GPS. Those GPS will cover India, and across India 1500 kilometer you can also watch. So proper India, Pakistan, India, China border, coastal areas, you can watch safe and secure this India in these bordering areas also. Entire India cover, but a part of it guys, 1500 kilometer more distance you can cover through the help of these 7 constellation of satellites. 7 constellation of satellites. Okay, this is my point. Now the question is how all the 7 constellation of satellites are working, and here I will clarify I'm very sure you will be clear here in the case of GTO. See how 7 constellation of satellites are working in the case of IRNSS. Again I repeat, I am not discussing you IRNSS. Through example of IRNSS, I want to discuss with you GEO and GTO. It will be very clear. Okay, see guys, suppose this is Earth. Suppose this is Earth. Suppose this is Earth. Okay, this is Earth. Suppose this is Earth. This is equator and this is India. This is equator and this is India. Okay, just try to understand it. And this is what? This is a 36,000 kilometer distance as a circular orbit. This is 36,000 kilometer distance as a circular orbit. Okay, what is the distance of it? 36,000 kilometer. What is the distance of it? 36,000 kilometer. Everywhere 36, it's a circular orbit. And here I can tell you this is what? This is the GEO orbit. Geostationary Earth orbit. This is the geostationary Earth orbit. Okay, see one thing. Suppose this is a football. Suppose this is a football. Okay, suppose this is a football. Okay, suppose this is a football. Okay, just a minute guys. Actually I need some more space. Just a minute. It's a circular orbit. Okay, everyone. Now, just imagine it's a football. Okay, and now I press the football from both to side. So it's a circular structure. Spherical body will bend like this, bend like this, bend like this, and it will stretch. Here it will stretch, and now it will connect here. 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 It's a what? It's a geostationary Earth orbit. Okay, and this is what? This is the geosynchronous transfer orbit. In the form of picture, I just try to define you. You see, guys. This is the geo as a circular. This G2 is the elliptical. Here I can tell you, geo is the circular. I hope you can see here, guys. Circular. And this is what? This is small elliptical. Elliptical is small elliptical, whatever you can call. Because of elliptical path, this distance will not be in 36,000. It will be 36,000 minus 5,000, 6,000 kilometer is possible. And this distance is not 36,000. It will be plus 36,000, 5,000, 6,000 kilometer. So 36,000 plus minus 5,000 to 6,000 is here elliptical. I hope you are getting my point. 3 satellites, 1, 2, 3 in GEO, and 4, 5, 6, 7 in the GTO. Okay, 7 constellation of satellite India has achieved. 1, 2, 3 number of satellites into the GEO orbit, and 4, 5, 6, 7 satellites. It is into the GTO orbit. And see the locations. See the location. One satellite is here. Second satellite is here, and third satellite is here. So 1, 2, 3 is what? It is in GEO orbit. It is in GEO orbit. Okay, everyone? Fine. I'll use some other colors. It's fine. It's the one is here, second is here, and third is here. 3 satellites are here. So this is what? This is a circular path where you people put the 1, 2, 3 number of satellites. 4, 5, 6, 7 satellites. 4 is here, 5 is here, 6 is here, and 7 is here. 4, 5, 6, 7 is here. So 1, 2, 3, 4, 5, 6, 7 here. Okay, everyone. And now see, guys, these all the 7 constellation. So 4, 5, 6, 7 is in elliptical path, and 1, 2, 3 in the circular path. I hope you clear. And now see, guys, these all the satellite will focus to India. See, focus India, focus India, focus India, focus India, focus India, with some other inclinations. Inclination angle means there are different way. As they penetrate, they see the India's images. Every inclination angles are different angles. They watch this India, and now through the help of 7 constellation of satellites, this entire India with 1500 kilometer bordering areas you can cover, and you can watch safe and secure this entire India. Okay, so I hope you people actually last one thing more, guys. These all features, those you people can see here, guys. These all features are geosynchronous orbit. These all features of geosynchronous orbit. So geosynchronous orbit you people have seen circular, geo, and elliptical, GTO. So I can tell you geosynchronous orbit is of 2 types. Generally, according to your examination, the one is geo type and second is a GTO type. That's why you people got it. Geo is a geosynchronous, but all geosynchronous is not geostationary. Reason, other option is a geosynchronous transfer also. You tell me this logic you clear or not? You tell me this logic you clear or not? I want everyone answer as yes. This logic you people clear or not? Just a minute guys, 1 minute. Okay, and I'll show you again one video here, okay, because there is many options. So I have a digital board, so I just want to give you some more informations here. Okay, so finally the concept will be really very helpful to you. It's a ISRO site video, IRNSS. I'll show you IRNSS video. I'll show you. Let me check, where is it? I think it's not. The problem is, when you search videos, so you are not getting. It's a ISRO wala video. Where is it? I'm not getting. Sorry guys. So it's fine. You people follow it. Okay. Neither again I will wait. And it's not difficult. You can understand. Okay. It's not difficult. You can understand in this way. But one thing I'll tell you, which is very, very important. Okay. One thing that is very, very important. All these 7 satellites. It's not downward side. Downward side have a south pole. All these satellites are here in this direction and they focus this India. They focus this India, guys. You people remember. So all those satellites are here in front of it. They focus this India. Okay, they are focusing this entire India. Okay, it's not downside. Okay, fine. So this is the entire concept. You people remember. Okay, everyone, fine. Now you come into the another orbit that is very, very important. This is called as a GPS orbit. Very good. Everybody is giving me response. Now come GPS orbit. GPS orbit. GPS orbit. See guys, there are 2 levels of GPS. Try to understand. There are 2 levels of GPS. There are 2 levels of GPS. The one that is called regional GPS. One is called as a regional GPS. And second is called as a global GPS. Regional GPS, those will cover your areas and maybe some outskirt areas, as you have seen in the case of IRNSS. In the reference of India, I'll give you 2 GPS name. The one is Gagan and second is a IRNSS. This is all the discussion I'll do in the space technology, but not here during the discussion of GPS technology. So Gagan and IRNSS, it's a regional GPS only for India, India's locations and across some distance from the bordering areas. But global GPS, it covers the entire world. This covered through entire world, not only the location of particular countries, even entire world images it cover. I have a question, guys. For global GPS, okay, for global GPS, which type of satellites we will use, in which orbit? So which orbit based satellite will be the best to cover the entire world images? Okay, to cover this entire images, I have a statement, guys. 2 orbits I'll discuss. One, the one is the polar orbit. You tell me, polar orbit is possible to cover entire world? Practically it is not possible. It is so much difficult, guys. Have a lot of difficulty here. Okay, it has a lot of difficulty here, guys. Okay, up to lot of difficulty here. If polar orbit, you will see. How so? Because you people have seen 30 minutes a polar satellite is working for India. Okay, and how 24 into 7 is possible? So it means just for next 30 minutes, new satellite will come in front of India. Again, after 30 minutes, new satellite will come in front of India. In that way, only to see India's images 24 into 7, at least 47 constellation of satellite you will use. Only for India. You just try to understand, if polar nature of satellite you want to use to see India 24 into 7, so at least 47 satellite is required or not? Definitely 47 satellites are required. And if you want to cover the whole world images, America, Japan, Russia, China, everything, if you want to cover to even in the case of global GPS, guys, polar region will also cover 24 into 7. Even ocean region will also cover 24 into 7. All Himalaya, all mountains, all Amazon forest, every Sahara desert, all should also come. So in that way, I can tell you guys, many thousand plus constellation of satellites is required. 1000 plus constellations are required. Maybe many of thousand. I don't know how much it is. Okay, practically, you tell me, guys, this huge number of constellation of polar satellite if you will install and try to cover the whole entire world. So definitely, guys, it is very difficult task, and that is the reason for global GPS purposes, polar nature of satellite in thousands and millions of the numbers constellation is impossible. We are not doing it. Okay, so practically you people understood polar nature of satellite for the entire world images is not possible. Okay, fine. Maybe somehow for certain countries, many constellation of satellite will do and we install. But for entire world image, it is not possible. Global GPS cover not only the land, even ocean, polar region, all forest, all hilly areas, everything. Then it will cover under the global GPS. Fine. Second one, guys. Second one, the second thing, guys. Even geo nature of orbit if we'll take. So polar is discarded. Polar is not possible. Now I am coming into the geostationary Earth orbit. If geostationary Earth orbit satellite we install, okay, so we can cover entire globe images. You just see, guys, in S.C. Verma 11-12 standard book, physics book, okay, there is some statements are written there. Minimum 3 constellation. You just try to understand. Minimum 3 constellation. Minimum 3 constellation of geostationary Earth orbit satellites can cover entire world images. How it is so? See, guys, how it is so. Try to understand. Okay. Satya, I know very well those questions you are asking about a Starlink project. Okay. Your answer I will give you, because one more guys even asked me earlier about the Starlink wala questions. Okay. That answer is after this entire discussion. Okay. Not here right now. Okay. Wait. Because first of all, you clarified. Then because before this, one guy also asked me about the Starlink project. Okay, base question, but I avoid, because after this, because this again the same question came after this discussion, I'll be there. Okay, fine. Wait. See one thing, guys. One thing. So minimum 3 constellation. How minimum 3 constellation of satellites work? You just come here, guys. In this case, see, but still have some negatives. Minimum 3 constellation of satellites according to S.C. Verma. If we people install, so entire world images will cover. See, the one satellite you put here. You see here, so you see, guys, okay, one satellite you put here, second and third satellite you put here. Okay, plane of equator, one satellite, plane of equator, second satellite, plane of equator, third satellite. And all 3 satellites focus the entire images of Earth. 120 degree, from here 120 degree, and from here what happened? 120 degree. So now 120, 120 and 120 degree, 120 degree. The whole entire Earth image is covered. You people are right. S.C. Verma is right. Minimum 3 constellation of satellite, but have some limitations. What about the limitations? See, guys, you just tell me, guys, if lie plane of equator and you want to see the Earth images, so tell me, Earth is a geoid shape. Something is spherical type. You know, orange shape, geoid shape. You know, Earth has a very specific shape, not proper spherical. It's called geoid, G-E-O-I-D, geoid shape. Hardly you people can see 60 degree, 70 degree north and 60 degree, 70 degree south, because Earth is, you know, something like this. So hardly you people can see 60 degree north to 60 degree south, because Earth is geoid shape. Earth is going to bend something looking like spherical top and bottom. So hardly 60 degrees south and 60 degree north you people can see. The same here in this case and same here in this case. But one thing more, guys, 60 degree, 70 degree beyond north and 60 degree, 70 degree beyond south, it should also cover. It should also cover, because you wanted to install global GPS. So how you can avoid 60 degree north and how you can avoid 60, 70 degree south areas? No, So this is the reason minimum 3 constellation you can use to cover the whole world images, but it will not provide all 100% images. Reason polar areas 60-70 north and 60-70 south, it will never covered. It will never. I've just put a satellites here. So it can focus hardly here up to here and hardly focus up to here. And what about beyond this distance? Beyond this distance. So here this is right, but 60-70. I'm just telling you 60-70 degree north to 60-70 degree south. Okay, only in between the area you can cover. Beyond it not possible, beyond it not possible. So this is the reason, guys, geostationary Earth orbit satellites will also not helpful to cover the entire world images. So one orbit, polar orbit, discarded, and now geo orbit I'm also going to discard. Now you people come. One more orbit, those discussion I have not done. What is the another orbit, those discussion I have not done? That is an inclined or transitional orbit. That is inclined or transitional orbit. That is inclined or transitional orbit. What about the inclined or transitional orbit? You people know very well. You know bending wala. Something not polar, even neither polar nor equatorial. In between, those angles are going to be happen. It is a part of inclined or transitional. Okay, it is a part of inclined or transitional orbit. Okay, it is a part of inclined or transitional orbit. Now come here. Actually, guys, these satellites are into the MEO orbit. These satellites are in MEO orbit. Okay, and see one thing. Here the satellite distance are around 20,000 kilometer from the Earth's surface. Here satellite distance are 20 kilometer from the Earth's surface. You just listen, guys. That is very, very important. You know, world's first GPS in 1970s. In 1970s, US installed, its name was a NowStar. It covered the whole entire world images. Its full name was a navigation, satellite and ranging. Navigation, satellite and ranging, it was a world's first global GPS, those installed in 1970s. Okay, for military purposes. Which country have this? US. Okay, and see, guys, in this case, total 18 constellation of satellites. Total 18 constellation of satellites US has done and then declared. And all the satellites was in inclined or transitional orbit. How it is? You just listen. See, this is the inclined or transitional orbit position I have discussed in the beginning. This is the inclined or transitional orbit. I'm going to put the satellite in 6 rows. Try to understand. I'm going to put the satellite in 6 rows. What about the 6 rows? 1 row, 2 row, 3 rows, 4 rows, 5 rows, and 6 rows. In 6 rows, I'm going to put the satellites. And in each and every rows, I'm going to put 3 satellites each. The total, how many constellation of satellites? 18 satellites. And now through the help of, and see, satellites not fixed. Satellites all may move with the certain orbital speed, you people know very well. And through the help of these 18 constellation of satellite, now whole world images cover as US declared in 1970 with the constellation of 18 satellites. It means minimum 18 constellation of satellite when US achieved in all inclined and traditional. How it is so? See, suppose this is 1 row. This is the 2nd row. This is the 3rd row. I just put 3 satellites in this row, 3 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 in this row. Total 6 rows, 3 each rows, total 18 constellations. Suppose this satellite is watching polar areas. When the first satellite is moving some distance, second satellite will come and again cover the polar areas. Second satellite is coming some distance, third satellite will come and cover the polar areas. When the third is coming, now the first already complete revolution, again watching the polar areas. So every time polar areas is going to cover. When one is not going to cover, second will come in place. When the second is not going to cover, third will come in that place. In that way, total 18 constellation of satellite if you'll do, satellites are moving, whole world images will cover. Okay, so for global GPS, you must have to install inclined and transitional nature of satellites. Okay, that MEO, medium Earth orbit, around 20,000 kilometer distance is the ideal place. Okay, around 20,000 kilometer distance is the ideal place. You people remember it. Okay, you people remember it. Now come. Okay, but what happened? With time, US increased this number, and today 30 plus constellation of satellites into inclined or transitional orbit. Maximum of the satellites in the inclined and transitional orbit, US installed, and now NowStar is working. And not only NowStar, today other countries like Russia also have a GLONASS. as a global GPS, and that global GPS also working through the help of constellation of inclined and transitional nature of satellite, but the number of satellite constellation around 30 plus in the case of Russia also. Okay, in the case of Russia also. Okay, now I'll show you one video also, and here in this video you will be very clear with the GPS orbit. Okay, you will be very clear with the GPS orbit, global GPS orbit. Okay, fine. Those India's regional GPS I have discussed. First of all, you people respond me that you people clear with all concepts. How global GPS will work. You just respond me how global GPS will work. See, one of the video is here, and through the help of this video I will clarify entire concepts. Where is that video? I'm very sure it is here somewhere. Where is the video? Yes, this is a video. Okay, and this video I'll discuss with you guys. Akshay, I'll give your answer. Okay, first let me finish this topic. Okay, great. Everybody's are getting great. Now come here, guys. Now come. This is the in this animations you can understand very well. Actually, this red color. Okay, this is just a minute. Not even any satellite you will get into the polar position. Not even any satellite polar position. Not even any satellite into the equatorial position. Every satellites are into the inclined and inclined and inclined. Means transitional. Means transitional. You know very well, guys. Means transitional. Not even any satellites are here. Not even any satellites are here. Every satellites are in between. If you see, you can get it. Okay, you go anywhere, guys. You go anywhere. You will definitely come under the range of, just like this is a person. As red color is a person, and this person is moving anywhere. This person is coming under this number of satellites visibility. This person is here. This person is here. Okay, this person is here. See, this value is going to change. Now this person is coming under, all the satellites are moving, but those color as red, that satellite is providing the position information of a person or object, wherever this person or object move. I hope through the help of this video you people understood. Okay, and India have not any global GPS. India have only regional GPS. Those Gagan and IRNSS. Okay, those regional GPS India have. Okay, sorry, India have only regional GPS. The Gagan and IRNSS. Still, there is no news that India is working for global GPS. Okay, IRNSS and Gagan, those India have a GPS. It's a regional GPS only. Okay, it's a regional GPS only. You people remember. Okay, it's a regional GPS only. And now I hope through the help of these animations, you people very clear. Number of satellite visibilities. Okay, but definitely you go anywhere on the globe, guys. You will definitely come under the range of any satellites. Okay, you will definitely come under the range of any satellites. I will take your 5-10 minutes more and just want to discussion about the launching stations. That is very important. Okay, you come into the discussion of launching stations. So a lot of the topic discussion I have discussed today. International launching station. So international launching station. International launching station. Okay, international launching station. And again I am repeating, guys, today's lecture make you different from all institution students. Even whenever you will discuss these all the topics, okay, you will get your knowledge. And whatever the UPSC asks the questions, I have shown you guys. Okay, why satellite is geostationary, you know very well. Live plane of equator, you know very well. What about limitation of geostationary? Geostationary cannot cover the polar areas. But if you want to see the polar areas wala feature, so remote sensing is good. Remote sensing is, because remote sensing every moment of time will pass from the pole and pole and pole. Okay, so there is somewhere you will get remote sensing is better. Other places you will get the geostationary is better. So depends. It's depend. Okay, everyone, it's depend. Which one is better in that cases? See one thing more. International launching station. Should I leave? छोड़ ही देता हूँ. Okay, fine. I'll leave today. Okay, because timing is not allowed right now. I'm here for 2-3 minutes regarding any doubts. But yes, tomorrow you inform me. International launching station is the next part of discussion. Okay, I'm here for just 1-2 minutes regarding your doubts. If you have any doubts, you can ask me. So you can ask me, guys. Yeah, you people have not any queries, guys. Okay, yeah, you people have not any queries. Tell me. Shares tomorrow. Okay. So no doubt, but you tell me, guys, like literally you people enjoy this class or not, because a lot of the concept I discussed. Okay, lot of the concept I discussed, and here you people literally different. So I just wanted to ask you, like those discussion I have done today, Starlink wala discussion even still left, so that I'll discuss tomorrow. That in the case of Starlink, okay, this Elon Musk is trying to install in many thousands a number of satellites. And now through the help of Starlink projects, and Starlink projects here, the satellites are into the low Earth orbit. Okay, and 1,000+ satellites already Starlink even installed. And in US, it is the news, through the help of Starlink, satellite-based internet services started. That discussion will come under the communication technology actually. This topic, Starlink project, but one thing I'll tell you is Starlink project based satellites, where the 12,000 satellite is the target throughout the world images, because here the satellites are what? Polar nature of satellites. They are going to install. Actually, you know, guys, what is the benefit of polar nature of satellites? If polar nature of satellite you will use for internet and all services, so signals will go and come back very soon. Reason polar are close to you. If geostationary type of satellite you will use for internet services, so lot of propagation delay happen. Signal will go to satellite and then come back to Earth. It takes so much time. But if nearby Earth satellites you will use, but nearby Earth satellite through, if you want to cover the whole entire world images, so multiple number are required. That's why 12,000 constellation of polar satellites, LEO position of satellites is the target of Starlink project. And then with the fastest internet speed, okay, the Starlink is planning to provide you. But for that purposes, you must have to install 12,000+ satellites. Those are the ambition of Starlink projects. I think you people know very well the CEO of this company. Okay, CEO of this company. Navik Shubham, it will come there under the IRNSS. Actually, IRNSS, it's another name is a Navik, Navigation Indian Constellation. That part will come under the GPS orbit. You just wait. Navik I'll discuss. Okay, thank you everybody. Have a good day.